Yeah, we know the magnetic field due to a circular wire, especially at the center. The voice is clear, and this you can see the screen.
Yes, sir.
Yeah.
Yes,
So
sir.
we know the magnetic field at the center of a circular wire, and provided the current flows in the circular wire like this. Yeah, the same current flows through all the elements. Suppose you divide this wire into a number of pieces, every element will have the same current, and this is possible only when you divide this wire into a small piece and then pass the current. So because if you want the same current to pass, then it should be like this. So you should have a small notch here, and then you have to connect the battery. So in this case, you will have the same current passing through this wire. Then the magnetic field at the center of the wire, what do you call V naught? And if the current is like this, you know, you can apply right hand rule, thumb rule, and you can find out the magnetic field. Or you can clasp this with right hand such that the thumb shows the direction of current. Of course, then the remaining fingers will show it like this. So like this, and the thumb will be like this. So they show the direction like this. Hope you can understand this. So magnetic field will be into, right? Since the current is moving up, you have to hold it like this, correct? I think you can follow this diagram. So fingers
sir.
are clasping it like this, and the thumb is showing above. That means the current is like this. So the magnetic field is like this. Mu naught Ni by 2r, 2 times the radius. So if r is the radius. So magnetic field is inside, and the formula is like this. Now suppose the coil is closed and the battery is connected anywhere on the circumference. If you take the 2 points on the, of course this is closed coil, closed loop, and it may be a square loop, it may be a circular loop, anything. So now if you connect it to a battery like this, here, like this, then what happens is, same current cannot be expected through both the wires. Of course, in one case you can expect the same current, that is if these 2 points are selected at diametrically opposite corners. Divide the coil into 2 symmetrical parts, that means select the 2 points at diametrically opposite corners. Then the current through both the halves will be same because the length is same. So you know that current is inversely proportional to resistance if potential difference is same, because I equal to V by R, and here the 2 ends must have the same potential difference. This part of the wire and this part of the wire must have the same potential difference since they are in parallel. So I can call this as one resistance, this as another resistance kept in parallel. So they should have the same voltage, whatever be the length of the piece, need not be at the diametrical opposite points. It can be of any size. So voltage is a constant. When voltage is constant, I is inversely proportional to resistance, but I is R is directly proportional to length. So I is inversely proportional to length. That means more the length, lesser will be the current. So current gets divided into 2, I1 and I2. I2 will be more since the length is less in this part, resistance is less, current is more. Here length is more, resistance is more, current is less. So currents will, the flow of currents will be different. So what type of magnetic field they will produce at the center? The magnetic field produced by the 2 coils, one is current clockwise, another is anti-clockwise. Definitely they will be in the opposite directions. Current produced by one half of the coil and another half of the coil will be in opposite direction. So if one produces a magnetic field like this, that is, I think outside the coil will be produced by I2, right? V2. Because if you clasp it, you will find that this current produces a magnetic field outside, and another coil produces magnetic field inside, because we have 2 coils here and neither of them have complete circle. It is a part of the circle. So I1 will be outside, inside. This will be into the paper and this will be out of the paper. Am I right? I think you can get it from this, right? So if you have the coil like this, I think you can see the video.
Yes, sir.
So if you have a coil like this, so the 2 parts of the coil are connected by a battery. So like this, So this part of the coil will carry current like this. This part of the coil will carry current like this. 1 minute. I will adjust it. How is it possible? Okay. Now you can see this. So this part of the coil, this one, this carries current in anti-clockwise direction. So you have to hold the fingers like this, right? Am I right? E part of the coil hege barutte. So that produces magnetic field outside, whereas this part of the coil carries current in this direction. So it carries the current. It produces a magnetic field inside. ಅಲ್ಲಿ ನಿಮಗೆ ಮಿರರ್ ಇಮೇಜ್ ಕಾಣ್ತಾ ಉಂಟಾ ಡೈರೆಕ್ಟ್ ಕಾಣ್ತಾ ಉಂಟಾ ಹೋಪ್ ವಾಟ್ ಮೈ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇಸ್ ಕರೆಕ್ಟ್ ದಿಸ್ ಪಾರ್ಟ್ ಆಫ್ ದ ಕಾಯಿಲ್ ಇದು ಒಂದ್ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಆಯ್ತು ಕರೆಂಟ್ ಸೊ ಅದರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹೊರಗೆ ಬರಬೇಕು ಈ ಪಾರ್ಟ್ ಆಫ್ ದ ಕಾಯಿಲ್ ಇದು ಉಂಟಲ್ಲ ಪಿಕ್ಚರ್ ಗೊತ್ತಾಗ್ತದೆ ಅದು ಸೊ ಐ ಆಮ್ ಟ್ರೈಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಸೊ ಇಟ್ ಈಸ್ ಲೈಕ್ ದಿಸ್ ಸೊ ಒಳಗೆ ತೋರಿಸ್ತದೆ ಆರ್ ಯು ಕ್ಯಾನ್ ಕ್ಲಾಸ್ಪ್ ರೂಲ್ ಹಾಕಿದ್ರೆ ಆಗ್ತದೆ ಸೊ ದಿಸ್ ಪಾರ್ಟ್ ಆಫ್ ದ ಕಾಯಿಲ್ ವೆನ್ ಇಟ್ ಇಸ್ ಕ್ಲಾಸ್ಡ್ ವಿತ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಅದು ಒಳಗೆ ತೋರಿಸ್ತದೆ ಅಂಡ್ this part of the coil adu clasp madbekare hige torisi itkolbeku so at the center of the coil it is showing outside magnetic field. Hope you have followed this. So this is this idan nan 2 anta tekondidane diagram alli, this is taken as 1. So B2 is outside out of the paper and B1 due to this one it is inside the paper, right? So they are definitely opposite. Now whether they produce a net magnetic field at the center, no, the net magnetic field is 0. ಇಲ್ಲಿ 0 ಆಗುತ್ತೆ net magnetic field. Why? B is equal to 0. Wherever you select the 2 points where you need to connect the battery, ಎಲ್ಲಿ ಬೇಕಾದ್ರೆ ನೀವು ಬ್ಯಾಟರಿಯನ್ನು ಕನೆಕ್ಟ್ ಮಾಡಿ the net field is 0. Because the field is decided by 2 things. One is number of turns and another is current. Radius is same for both the parts. ಇದರ ಈ part of the coil ಎಷ್ಟು ರೇಡಿಯಸ್ ಮಾಡ್ತದ ಈ part of the coil ಕೂಡ ಅಷ್ಟೇ ರೇಡಿಯಸ್ ಮಾಡ್ತದೆ, no problem. Radius is a constant, so this denominator is a constant. Mu naught is a constant. Ni product decides. See here, number of turns is less. Say ಇದಕ್ಕೊಂದು ಸುಮ್ಮನೆ angle ಕೊಡುವ. Say this is 90 degrees. Then remaining is 90 degree means 1/4 of the coil ಆಯ್ತು. 3/4 ಈ ಕಡೆ ಇದೆ. So here the turns is 3/4. That means length is almost 3/4 of the total circumference. But current is less. Current 4/3 ಆಗ್ತದೆ ಆಗ because length is directly proportional to resistance, but it is inversely proportional to current. So here number of turns is more 3/4, but current is 4/3. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ current is more, that is 3/4, but number of turns 4/3 ಆಗ್ತದೆ. So ಒಂದಕ್ಕೊಂದು ಹೊಡಿತಾ ಹೋಗ್ತದೆ. So the net magnetic field produced by the 2 parts of the coil, this one and this one, are equal because Ni product is same. ಈ product same ಬರ್ತದೆ. Number of turns ಜಾಸ್ತಿ ಇದ್ರೇನು current ಕಮ್ಮಿ ಇರ್ತದೆ. Here number of turns ಕಮ್ಮಿ ಇದ್ರು current ಜಾಸ್ತಿ ಇರ್ತದೆ because length is less. So this is a constant. So what happens is magnetic field produced by this part of the coil and this part of the coil are equal in magnitude. So if you are asked to write what is B1 by B2, it is nothing but 1 ratio, but net magnetic field at the center is 0. Hope you have followed.
Yes, sir.
Yeah. It may be true for any 2 points. It may be diametrically opposite, 1/4, wherever it is. Hege divide adru current adjust ಆಗ್ತಾ ಹೋಗ್ತದೆ ಅದಕ್ಕೆ, so that this product remains the same. Suppose you have a rectangular loop like this. Again, it is closed. We don't open it and we don't find out the magnetic field. Open ಮಾಡ್ತಾ ಇಲ್ಲ, close ಇದೆ ಇದು. So you connect a battery here. Whether you connect a battery here, ಇದೀಗ 3/4 1/4 ಆಯ್ತು. 50-50 ಅಲ್ಲಿ connect ಮಾಡಿ. So connect a battery here, whatever it is. The magnetic field at the center is 0 because this will carry anti-clockwise current, this will carry clockwise current, so that one magnetic field will cancel the other one, net magnetic field will be 0. So even it is true for this type of structure also. So ಇದೆಲ್ಲದಕ್ಕೂ ಸೇಮ್ ಬರ್ತದೆ. ಒಂದೇ ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ Ni product ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರ್ತದೆ. So that is one thing. So ಇದಕ್ಕಿದಕ್ಕೂ ಡಿಫರೆನ್ಸ್ ನೋಡ್ಕೋಬೇಕು. Where did you connect the battery. If you open it and connect it, the story is different. So if you open a rectangular coil or a square coil, square loop, open it here and connect a battery so that all the sides have the same length, then the magnetic field at the center is not zero. So current will flow like this. There is a current, and net magnetic field will add up due to all the wires. ಅದಕ್ಕೆ ಬೇರೆ ಮೆಥಡ್ ಇದೆ. That we will see later. Okay. So ಇದೊಂದು ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು. Ratio of magnetic field produced by the two parts of the coil at the center is B1 by B2. That is 1. Net magnetic field at the center is 0. Okay. Then whenever a coil is given, a part of the coil is given, how to identify its number of turns as a part of circumference or as a part of angle? Suppose if I have a wire with an angle making at its center, I have a part of a wire, that means I have an arc of a circle which is making an angle theta at the center. I have an arc of a circle, theta angle at the center. So I be the current through this arc of the circle. Ivaga, you know what is the magnetic field at the center of a coil? That is mu naught Ni by 2r, 2 times the radius. R be the radius. Now, how to find out? ಈಗ ಇದನ್ನ DL ಅಲ್ಲಿ DL ಅಂತ ಕೊಟ್ರೆ, say suppose this length is DL. Now how to convert this into the angle theta? Suppose if I take it, okay. Now DL ಇದನ್ನ ಒಂದು ಇದು ಮಾಡಬಹುದು. You can use one method is R d theta. So DL is equal to R d theta. And number of turns ಅನ್ನು ಹೀಗೆ ಮಾಡಬಹುದು. 2 pi r turns. Suppose ಇದು full 2 pi r ಇರ್ತಿದ್ರೆ 2 pi r turns makes an angle of how much? 2 pi.
360 degree.
Yes, 2 pi. What about DL turn? That is theta. ಈ DL turn theta ಆಗುತ್ತೆ. So 2 pi r makes full turn, makes 2 pi angle. What about DL turn? Makes an angle theta. So theta is equal to ಇದು DL by R ಆಯ್ತು. R equal to d theta ನೇ ಫಾರ್ಮುಲಾ ಆಯ್ತಿತ್ತು. ಇದು ಸಿಂಪಲ್ ಆಗಿ ಬರಿಬಹುದು. DL is equal to R d theta. ಅದು ಬಂತಲ್ಲ. Then you can substitute this one. ಒಂದು ಇದನ್ನ ಮಾಡಬಹುದು. And number of turns ಹೇಗೆ ಮಾಡಬಹುದು? 2 pi r means 1 turn. ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಸೊ ಇಲ್ಲಿ r ಗೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಇನ್ನೊಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ 2 pi r means 1 turn. ಯಾಕಂದ್ರೆ number of turns ಎಷ್ಟು ಅಂತ ಗೊತ್ತಿಲ್ಲ ಇದು. It is whether it is 50, so 50%, half turn, 3/4 ಗೊತ್ತಿಲ್ಲ. 2 pi r makes 1 turn. DL length makes how much turn? So that is n. So ಇದನ್ನ ಎರಡನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ I think you will get it in terms of theta. Of course ಇದನ್ನ d theta ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೇನೆ. So magnetic field at the center due to an arc of a circle B is equal to mu naught. Number of turns is DL by 2 pi r. Number of turns I by 2r. R ಅನ್ನ DL by d theta ಬರಿಬಹುದಲ್ಲ. R is equal to DL by d theta. ಇದು 2 pi r ಇದ್ರದ್ದಾಯ್ತು. ಇಲ್ಲಿ 2 times r ಇನ್ನೊಂದುಂಟು. Isn't that? ಇಲ್ಲಿ ಒಂದು 2 ಕ್ಯಾನ್ಸಲ್ ಆಗ್ಬೇಕಾ? mu naught by Ni by 2r. Mu naught n is correct ಉಂಟಲ್ಲ? mu naught n is DL by 2 pi r. ಇನ್ನೊಂದು 2 ಇದೆ. ಈ 2 r is DL by d theta. Sorry, DL by d theta. DL by d theta. ಅವಾಗ DL cancel ಆಗ್ತದೆ. That is of no use now for us. mu naught by 4 pi ಬರ್ತದ. mu naught by 4 pi I theta by r. I d theta by r. Okay. 4 ಬರ್ತದ ಇಲ್ವಾ ಅಂತ ಒಂದು ಡೌಟ್ ನನಗೆ. Or you can do it using that Biot-Savart's law. How do you use Biot-Savart's law? ಅದನ್ನ ಹಾಕೊಂಡು ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ತದೆ. So you have a coil like this, a wire carrying current, and you take a small part of the wire that is of length dl, right? And I is the current through all the components, and the magnetic field somewhere here, and this is the direction of that current element. If it makes an angle theta here, you write the formula dB is equal to mu naught by 4 pi IDL sin theta by r square. Idon formula untala. If r is the distance from the point to the so here you are finding the magnetic field. dB is equal to mu naught by 4 pi IDL sin theta by r square. Correct alla?
Yes, sir.
And remember here theta, e theta ku difference ide. This theta is the angle between the direction of current element and the position vector r. Position vector r gu a element gu iru angle theta. That angle, if you search it here, it is the direction of element, current element, like this. Current element is a vector. So I into dl vector agutte. So this direction and the r direction. This is wherever you take the r, it is always 90 degree, because radius vector always makes an angle 90 degree with the element. So I dl, I cross dl, sorry, dl cross r adu actually. Illi r cube bartade. So dl sin theta sin 19 agutte. Am I right? So what is the magnetic field due to a arc of length dl subtending an angle theta at the center? ದೊಡ್ಡದಾಯ್ತು arc. ಅದು 4 pi ಬರ್ತದ ಅಂತ. Yes, because now the 4 pi ಎಲ್ಲ ನಾನು ಅದನ್ನ ಅಷ್ಟು ನಾವು ರಿಲೇಷನ್ಸ್ ಮಾತ್ರ ನೋಡ್ಕೊಳ್ಳೋದು. So like this, so this is d theta, and this theta is 90. So what is the magnetic field at the center? dB is equal to ಈ ಎಲಿಮೆಂಟ್ ನ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ r ಆಗುತ್ತೆ, because we are finding the magnetic field here. So ಇದನ್ನೇ ಕರ್ವ್ ಅಂತ ತಗೊಂಡ್ರೆ ಆಯ್ತು. dB is equal to mu naught by 4 pi IDL sin theta is sin 90 by r square. Now you write dl is equal to r d theta, mu naught by 4 pi IDL, dl is r d theta, sin 91 ಆಯ್ತು by r square. So mu naught by 4 pi 4 pi ಬರ್ತದೆ ಹಾಗಾದ್ರೆ. dB is equal to magnetic field due to a arc of a circle mu naught by 4 pi I d theta by r. Same bantala, right?
Yes, sir.
Magnetic field due to idu in terms of angle aitaga. In terms of angle subtended by the arc at the center, what is the magnetic field at the center? The first formula for the number of turns adu mu naught ni by 2r. Idu. This is in terms of number of turns. This is in terms of arc of the circle. The angle subtended by the arc at the center. Okay. Now, idu one part ಆಯ್ತು. Magnetic field due to a circle, and you know the magnetic field due to a straight wire, the magnetic field is always in a plane perpendicular to the straight wire, and and it is in the form of concentric circles. So like this. If the current is like this, you can use the clasp rule. With the right hand, you have to encircle it like this. So thumb illi bartade. So then the fingers show like this. You know it, right? Idella gottu. They are in the form of concentric circles. Magnetic field is always found in a plane perpendicular to the conductor, plane of the conductor. Now, what is the magnetic field strength in terms of this clasp rule, left hand rule? ಇದೆಲ್ಲ ಫೋರ್ಸ್ ಅನ್ನ ಅಥವಾ ಏನೋ ಒಂದು ಡೈರೆಕ್ಷನ್ ಮಾತ್ರ ತೋರಿಸೋದು, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಕೊಡಲ್ಲ. ಸೊ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಬೇಕು ಅಂತಾದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ಬಯೋಟ್-ಸವರ್ಟ್ಸ್ ಲಾ ಆರ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಎ ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್, ಅದಕ್ಕೆ ಹೋಗ್ಬೇಕು. ನಾವು ಸಪೋಸ್ ಯು ಹ್ಯಾವ್ ಎ ಸ್ಟ್ರೈಟ್ ವೈರ್ ಕ್ಯಾರಿಂಗ್ ಕರೆಂಟ್ like this, but of limited length. Infinite length ಗೆ ನಮ್ಗೆ ಗೊತ್ತು, ನಾವು ಡಿರೈವ್ ಮಾಡಿದ್ವಿ ಯೂಸಿಂಗ್ ಆಂಪಿಯರ್ ಸರ್ಕ್ಯೂಟ್ law, we derived it. But now suppose you have an a straight wire carrying current, and if you want to find out the magnetic field at a point at a certain distance from this, illinda ನಾವು ನೋಡ್ಬೇಕು magnetic field. So if it is like this, okay, ನಾನು ಸ್ವಲ್ಪ ದೂರ ತಗೊಳ್ತೇನೆ magnetic field. Yes, like this, like this. So it is somewhere here. Illi tagoltini nanu. Ellu irbodu adu. It may be very close to this point or this point. Suppose this is phi1 and this is phi2. This formula we are not discussing it in the theory. So if this is r distance, what is the magnetic field here? ಆಮೇಲೆ ಅದನ್ನು infinitely long wire ಗೆ ತಕ್ಕೋಬಹುದು. A wire of definite length, not infinite length, producing magnetic field in its neighborhood. Illiga class rule ಹಾಕಿದ್ರೆ you know that the magnetic field is in the form of circles like this. Then the magnetic field at this point is given by mu naught by 2 pi, sorry, mu naught by 4 pi, 4 pi is standard, mu naught by 4 pi I by r into sine phi1 plus sine phi2. This gives the magnetic field due to a straight conductor at a point. But we derive it using Ampere's circular law. I don't go for the derivation. For an infinitely long straight wire, infinitely long aguvaga, for example, if you see the cables of electricity, KPTCL cables, from one pole to another pole, compared to the distance, compared to the length of the wire, if you select a point which is suppose 1 feet away from the wire, the length of the wire is very large. So 1 feet away ನೀವು ಒಂದು magnetic field ನೋಡಿದ್ರೆ, that distance is very small compared to the whole length. ಆವಾಗ ಅದು infinitely long ಅಂತ ತಗೊಳ್ಬಹುದು ನಾವು. So an infinitely long wire and select a point here and at a distance r, ಆವಾಗ ಏನಾಗ್ತದೆ? So this distance will be very small then. ಆವಾಗ ಈ angles ಏನಾಗ್ತದೆ ಅಂತ ಹೇಳಿದ್ರೆ, when you select a point, ಅದು close ಆಗೇ ಆಗಬೇಕಾ? If the wire is very long, whatever this point you select across the wire or surrounding the wire, it should be very small compared to the length. ಆವಾಗ ಏನಾಗ್ತದೆ? This position, ನಾವು ಇಲ್ಲಿ ಮಾಡಿದ್ರೆ, this position will become, this will become 90 and this will become 90. So if the wire is infinitely long, for any point at the center of the wire, ಅಂದ್ರೆ wire ನ edge ಗೆ ಬರುವ ಬದಲು middle ಅಲ್ಲಿ, ಅಂದ್ರೆ middle portion ಅಂದ್ರೆ ತುಂಬಾ ಇರ್ತದೆ ಅದು. If the wire is very long, wherever you go, it will be almost middle of the wire. Suppose you are put in the sea, some 10 kilometers away from the shore. Of course, it is the middle of the sea for you because you can't swim on the either sides. 10 kilometers ಈ ಕಡೆ ಬರ್ಲಿಕ್ಕೂ ಆಗೋಲ್ಲ, thousands of kilometers ಆ ಕಡೆ ಈಜ್ಲಿಕ್ಕೂ ಆಗೋಲ್ಲ. ನಿಮ್ಗೆ ಎರಡು ಸೈಡ್ ಇನ್ಫಿನಿಟಿ ಅದು. So when the wire is very long, midpoint ಅಂದ್ರೆ exact midpoint ಗೆ ಹೋಗ್ಬೇಕಾಗಿಲ್ಲ. Anywhere it is midpoint. So now what is the magnetic field here? So both become sine 90, sine 90. ಅವಾಗ ಏನಾಯ್ತು? Magnetic field at the center of a very long straight wire, V is equal to mu naught by 4 pi I by r, and this is sine 90, sine 90, 2I by r ಆಗ್ತದೆ. Correct?
Yes, sir.
Yes. Right. Edge ಗೆ ಹೋದ್ರೆ, ಸರ್ ನಾವು wire ನ edge ಗೆ ಹೋಗುವ. So if suppose you are in the seashore, of course you are in the edge, and other side of the seashore is at infinitely large distance compared to your swimming. Swimming ಗೆ ಕಂಪೇರ್ ಮಾಡಿ, ಶಿಪ್ ಅಲ್ಲಿ ಹೋಗ್ಬೋದು, ಅದು ಬೇರೆ ವಿಷಯ. ಸ್ವಿಮ್ಮಿಂಗ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ you are at an infinite distance. So ಇವಾಗ suppose the wire is infinitely long and if you are at the edge, then what happens is when you come to the edge, this phi1 becomes 0. You can imagine it, right? ಇದು ಮೇಲೆ ತರುವಾಗ ಇದು ಎರಡು ಆಂಗಲ್ 0 ಆಗ್ತದೆ. And this becomes almost 90. Idu 90 ಆಗ್ತದೆ. So when I take that position from another edge, this becomes 90. So one becomes sine 0, another becomes sine 90. So what is the magnetic field at the edge? Mu naught by 4 pi I by r into sine 90 zeros, sine 0 0, sine 91, 1 I by r, which is half of that at the center. So magnetic field, ಈಗ ಇದನ್ನ ನಾನು magnetic field at the edge ಅಂತ ತಕೊಂಡ್ರೆ, magnetic field at the center ಅಂತ ತಕೊಂಡ್ರೆ, BC is double the magnetic field at the edge. At the edge, mu naught by 4 pi I by r. At the center, magnetic field is mu naught by 4 pi 2I by r. So ಈ ಫಾರ್ಮುಲಾ ನಮಗೆ ತುಂಬಾ ಕಡೆ ಹೆಲ್ಪ್ ಆಗ್ತದೆ. Magnetic field due to different shapes find out ಮಾಡ್ಲಿಕ್ಕೆ. Okay. ಇಲ್ಲಿ ಇದೆ ಅದು ಸಿನಾಪ್ಸಿಸ್ ಎಲ್ಲ ಮತ್ತೆ ಕೊಡ್ತೇನೆ ನಾನು, ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಂತ. ಸೊ ಇದೊಂದು ಎಕ್ಸ್ಟ್ರಾ ಫಾರ್ಮುಲಾ, I theta by r. ಎಸ್, ಕರೆಕ್ಟ್ ಇದೆ ಫಾರ್ಮುಲಾ. B is equal to mu naught by 4 pi I theta by r. and another one is mu naught by 4 pi I by d, that is at the edge, 2 I by d at the center. ಇದು 2 pi ಅಲ್ಲಿ ಉಂಟು, ಅದನ್ನು 4 pi ಅಲ್ಲಿ ಬರೆಯೋದಾದ್ರೆ ಕಾಮನ್ ಮಾಡ್ಕೊಳ್ಳೋದಾದ್ರೆ at the end it is I by d, at the okay 4 pi, ಇಲ್ಲಿ 4 pi ಇದೆ, 2 2 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದಾರೆ ಅಷ್ಟೇ. yes 4 pi ಇದೆ. at the center it is mu naught by 4 pi, ಇದನ್ನು ಬರ್ಕೊಳ್ಬೇಕಾದ್ ನಾವು. yes here mu naught by 4 pi 2 I by d at the center. ಇಲ್ಲಿ ಒಂದು 2, ಇಲ್ಲಿ ಒಂದು 2 multiply and divide ಮಾಡ್ಕೊಂಡ್ರೆ ಆಯ್ತು, sin 90 plus sin 90. so it is available in the, ಅದು ಮತ್ತೆ ನೋಡ್ಕೊಳ್ಬಹುದು. so apply ಮಾಡುವಾಗ ಒಂದಷ್ಟು ಗೊತ್ತಾಗ್ತದೆ ಹೇಗೆ ಅಂತ. so how to find out the magnetic field due to different shapes of the wires, infinitely long illade idre, so how to do that? Yeah, here I have given some examples. Here you have 2 circular wires, concentric circles, and they are carrying current in the same direction. You see, current in the same direction. so if you apply the right hand thumb rule, you know, if you have a coil carrying magnet, you see that video, hige bandre, and if you want to find out the magnetic field, if the current is in this direction, you hold the fingers like this, right? Hige hiditiri. That means if you hold it like this, because current is like this, so hige idkondre the magnetic field comes out like this. Correct? Thumb represents the direction of magnetic field. ಯಾವಾಗಲೂ ನಮಗೆ ಕ್ಲಾಸ್ ರೂಲ್ ಅನ್ನ ಸ್ಟ್ರೈಟ್ ಕಂಡಕ್ಟರ್ ಹೇಗೆ ಆಗ್ತೇವ, suppose this is a straight conductor carrying current, hope you can see this straight conductor carrying current like this. What is the direction of magnetic field? We clasp it with the right hand such that the thumb shows the direction of current. Then the remaining fingers show the direction of magnetic field. Remaining fingers, you see how they are. So it should be remaining fingers higidre, so it should be like this. hige barbekadu. Remaining fingers show like this. Okay, like this andre, okay, it should be like this, so they should be like this. so ee tara. ಈಗ ಇಲ್ಲಿ 2 circles adu, both are circles and they are concentric circles, and they are carrying current in the same directions. so one circle is like this, circular wires with the center same higide. so both are carrying currents like this and like this. so both the magnetic fields should come out of the paper, right? They should add agbeku. am I right?
yes sir.
ಇದು ಯೂಸ್ ಆಗ್ತದಾ ಇಲ್ಲಿ ಹೇಳಿದ್ರೆ? ಕಾಣ್ತಾ ಉಂಟಲ್ಲ ಅದು ನನಗೆ ಚಿಕ್ಕದಾಗಿ ಕಾಣ್ತದೆ. yeah, they come out. so if you come back to this now, they are carrying current in the same direction, so you have to add them. suppose you are given some directions, ಇಲ್ಲಿ already ಒಂದು directions ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಇಟ್ಕೊಳ್ಳುವ. that means say out of the board k cap, I cap, j cap ಅಂತ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ ಅಂತ ಇಟ್ಕೊಳ್ಳುವ. final magnetic field is out of the board, so it is k cap ಬರ್ಬೇಕು, ಇಲ್ಲಿ ಕೊಟ್ಟಿಲ್ಲ ಇವಾಗ. so what you have to do now? the only thing that is variable for the 2 coils is R1 and R2, radius matra, number of turns full 1. so the net magnetic field, I think I would write it as B into k cap, right? or B is equal to mu naught Ni by 2R. I same I1 I2 untu, same I here, I here, mu naught Ni, ನಮ್ಮ ಫಾರ್ಮುಲಾ ಹೇಗೆ ಅಂದ್ರೆ mu naught Ni by 2R. ಸೊ ನಿಮ್ಗೆ ಇದಕ್ಕೆ ಬರೆಯುವಾಗ mu naught 1I by 2R1, ಓಕೆ ಫುಲ್ ಬರೆಯುವ ಬೇಕಾದ್ರೆ mu naught 1 turn I by 2R1 plus mu naught 1I by 2R2. I same, R1 R2 ಮಾತ್ರ ಡಿಫ್ರೆಂಟ್, and both are along k cap outside the, ಇದು ಹೀಗೆ ಕೊಟ್ರೆ ಅವರು ಇಲ್ಲಿ ಡಾಟ್ ಕೊಟ್ರೆ, ಡಾಟ್ ಅಂದ್ರೆ ಔಟ್ ಆಫ್ ದ ಬೋರ್ಡ್, k cap ಇರಬೇಕು. so this is also k cap. so what is the net magnetic field? mu naught I by 2 into 1 by R1 plus 1 by R2. is it okay? Okay,
yes sir.
yeah, ಇಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಟರ್ನ್ಸ್ ಜಾಸ್ತಿ ಇದ್ರೆ n ಹಾಕೊಳ್ಬೇಕಷ್ಟೇ. ಇವ್ರು ಪುಟ್ n ಒಂದ್ರಲ್ಲಿ ಜಾಸ್ತಿ ಒಂದ್ರಲ್ಲಿ ಕಮ್ಮಿ ಇದ್ರೆ, so very simple ಇದು. k cap ಇಲ್ಲಿ ಬಾಕಿ ಆಗಿದೆ. if you want to write the vector here, you should have k cap. ಓಕೆ, ಇದು ತುಂಬಾ ಈಸಿ ಉಂಟು ಈಗ, ಬಿಕಾಸ್ ಇಲ್ಲಿ ಆಕ್ಚುಲಿ ಕೊಟ್ಟದ್ದು ಅವ್ರು 1 ಟರ್ನ್ ಇಲ್ಲಿ ಹಾಕೊಂಡಿದ್ದಾರೆ, n ಹೊರಗೆ ತೆಗೆದ್ರು n ಗಳು 1 ಅಂತ ಹಾಕೋಬೇಕಲ್ಲ. ಆಕ್ಚುಲಿ ಒಂದೇ ಟರ್ನ್ ಕಾಣ್ತಾ ಇದೆ ಅಲ್ಲಿ. ನಾ This is the magnetic field produced by two wires, but in the opposite direction current. So radius different, current opposite. So magnetic field is vectorally vapas k hage idre. Suppose this is dot is k and this is j and this is I. Magnetic field is out of the board because you can have this rule out of the board. The current. So so what you will get now, B is equal to mu naught Ni, N ಅವರು 1 ಅಂತ ತಗೊಳ್ಳಿಲ್ಲ, by 2 R ಅಲ್ಲಿ difference 1 by, ಈಗ ಯಾವ್ದನ್ನ ಫಸ್ಟ್ ಬರೆಯೋದು ಯಾವ್ದನ್ನ ಮೈನಸ್. So you know that one coil carries current like this, so out of the board, out of the paper. Another coil, outside coil carries current into the paper, coil carries current in the clockwise direction. So adra magnetic field into the paper ಬರ್ಬೇಕು, hope, isn't it? Into the paper ಬರ್ಬೇಕಲ್ಲ. So ಅದನ್ನ ಮೈನಸ್ ಮಾಡ್ಬೇಕು. ಯಾರಿಂದ ಯಾರನ್ನ ಮೈನಸ್ ಮಾಡೋದು? You should subtract the stronger field and the weaker field from the weaker field from the stronger field. So how to subtract them? Yav the weaker, yav the stronger. Both the magnetic fields are decided only by the radius. Their magnitude is decided by the radius. Everything is same. Number of turns same, current same, 2 same, mu naught is a constant. So radius will decide. One which has got lesser radius, nama general formula, mu naught Ni by 2R. One which has got lesser radius will have more magnetic field. That means R1 is stronger. R1 na current hegide, it is clockwise. So how is its magnetic field? Outside or inside? R1 is hegide current. So idra magnetic field outside barbeka inside anta? Kelta ilva?
Outside.
It should be outside, right? Adu higidre it should be outside, correct? Idu idralli video dalli confusion agta unta?
No, sir.
Okay, correct alla agidre it should be outside. So agidre 1 by R1 first ge barbeko minus 1 by R2 into k cap. Why k cap? Why not minus k cap? Yakandre R2 iddu minus k cap alla. R2 will produce a magnetic field which is inside. R2 inside ಬರಬೇಕು because its current is like this. ಆ ಕರೆಂಟ್ ಅಂತ ತಗೊಂಡು ಹೋದ್ರೆ ಒಳಗೆ ಬರಬೇಕು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಬಟ್ ಅದು ಸ್ಮಾಲರ್ ಇರ್ತದೆ. ಸೊ ದ ಇನ್ಸೈಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಸ್ಮಾಲರ್, ಔಟ್ಸೈಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಲಾರ್ಜರ್. ಸೊ ಫೈನಲಿ ಕೆ ಸರ್ವೈವ್ಸ್, ಮೈನಸ್ ಕೆ ಬರುದಿಲ್ಲ. ಇಲ್ಲಿ ಮೈನಸ್ ಕೆ ಕ್ಯಾಪ್ ಬರ್ತದೆ. ಹೋಪ್ ಯು ಫಾಲೋಡ್ ದಿಸ್, ರೈಟ್? ಇದು ಈಸಿ ಇದೆ, ರೈಟ್? ಶಾಲ್ ವಿ ಮೂವ್?
Yes, sir.
Now tell me, what is the answer? Circuit coil is connected to a circuit at the center of the coil. Islate beka? What is the magnetic field at the center?
0.
0. Kelta ide nan question. So it is 0. B is 0 because you know wherever you select the 2 points, the coil will send the currents in clockwise and anti-clockwise direction, so that magnetic field produced by the two coils will be in opposite and they are equal in magnitude. Net magnetic field is 0. Okay. Yes, electron revolving around the nucleus in a circular path. Yes, that is also a source of magnetic field. It produces magnetic field at the center. Suppose you have an electron revolving around the nucleus in circular orbit. Adra actually period of revolution kotre better irtade. So what is the magnetic field here? Illi now carefully irbeku that it is an electron revolving around the nucleus, not the current. So if an electron revolves around the nucleus like this, you know that this is the path of electron. What is the direction of current? Direction of current is opposite. So idan now bitre current direction is like this. Am I right? Sariya?
Yes, sir.
So ಈಗ ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಇದ್ರೆ ನಾವು ತಂಬನ್ನ ಹೀಗೆ ಹಿಡಿಬೇಕಲ್ಲ. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಹೋಲ್ಡ್ ದ ಕ್ಲಾಸ್ಪ್ ರೂಲ್ ಲೈಕ್ ದಿಸ್. ಅಫ್ ಕೋರ್ಸ್ ಇಲ್ಲಿ ಕ್ಲಾಸ್ಪ್ ರೂಲ್ ಅಲ್ಲ, ದಿಸ್ ಇಸ್ ದ ರೂಲ್ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಎ ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್. ಯು ಹೋಲ್ಡ್ ದ ಫಿಂಗರ್ಸ್. ಇದರಲ್ಲಿ ಟು ಫೈಂಡ್ ಔಟ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಎ ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್ ನಾವು ಕ್ಲಾಸ್ಪ್ ರೂಲ್ ಅನ್ನ ಉಲ್ಟಾ ಹಾಕೋದು. ಅದು ನಾನು ಹೇಳಿಲ್ಲ. ಐ ಥಿಂಕ್ ಯು ಹ್ಯಾವ್ ಫಾಲೋಡ್ ದಿಸ್. If you have a straight conductor, if you want to find out what is the magnetic field due to the straight conductor, hold the thumb in the direction of current then the remaining fingers show the direction of magnetic field. Adu ಹೀಗೆ ತೋರಿಸ್ತದೆ. So they show like this. What about in a circular coil? Fingers should show the direction of current, then the thumb shows the direction of magnetic field. Fingers current ತೋರಿಸಬೇಕು. So ಇಲ್ಲಿ current ಹೀಗೆ ಉಂಟು. Current is in this direction, opposite to the flow of electrons. So the thumb shows inside. So magnetic field is inside. Any doubt?
No, sir.
Yes. So current hೀಗೆ ಆಯ್ತು. ಇದು electron motion. Current ಹೀಗೆ. So you have to hold the all fingers like this. So magnetic field is inside. ಹೀಗೆ ಬಂತು. Now ಇಲ್ಲಿ ಒಂದು ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. You need not by heart it. If you know the magnetic field due to a coil, then it is enough. You can bring up to this. ಇಲ್ಲಿ velocity ಕೊಟ್ಟಿದ್ದಾರೆ. V is the velocity of electron. But in terms of velocity, how to express it, sir? ಇಲ್ಲಿ ನೋಡಿ ಇದು radius. Radius of the ಅದು ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. Radius of the circular coil. Sir, how to express it in terms of velocity? First of all, you write the magnetic field due to a coil, as you know, that is mu naught Ni by 2R. And remember here, no current exists. So ಹಾಗಾದ್ರೆ ಕರೆಂಟ್ ಅನ್ನ ಹೇಗೆ ಅವರು ರಿಪ್ಲೇಸ್ ಮಾಡಿರ್ಬೋದು? dq by dt ಅಂತ ಮಾಡಿರ್ಬೋದು. dq by dt. And dq by dt is nothing but here electron moving around, but our finally q ಅಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾರೆ. So let us say that when I watch here, I will just observe the electron moving like this. ನನಗೆ ಇಲ್ಲಿ electron ಪ್ರತಿ ಸಲ ಸಿಗ್ತದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳು. I can see the electron. Suppose the electron takes or it completes one full circle. ಆಗ number of turns ನಾನು 1 ಅಂತ ತಗೊಳ್ಬಹುದು. ಅಥವಾ number of turns ಅನ್ನು n ಅಂತಲೇ ಇಟ್ಕೋಬೇಕು. Whatever it is. ಹೇಗೆ ಬೇಕಾದ್ರೂ ತಗೊಳ್ಬಹುದು. ನಾನೀಗ 1 ಸೆಕೆಂಡ್ಗೆ ಮಾಡ್ತಾ ಹೋದ್ರೆ if I do everything for 1 second, ನನಗೆ ಈಸಿ ಆಗ್ತದೆ. I equal to dq by dt. So I is equal to E ಆಗ್ತದೆ ಆಗ. Right? I will do it for 1 second per second. ಅಥವಾ ಸೇಮ್ ಟೈಮಿಗೆ ಮಾಡ್ತಾ ಹೋಗುವ. If you are confused, I will do it for same time. I is equal to E by t. ಅಥವಾ q by t. Okay? ಅವರು q ಯೂಸ್ ಮಾಡಿದವರಲ್ಲ. It can be applied for any charge. So I equal to q by t ಅಲ್ಲಿ ಹಾಕ್ಬೋದು. So ಒಂದು substitution ಆಯ್ತು. Then ಈ number of okay, what else I can do? Yes, B is equal to mu naught I is mu naught n by 2a. I is q by t. Okay. Now what is velocity? Velocity is equal to displacement by time or distance by time. ಇಲ್ಲಿ speed ತಗೊಳ್ಳುವ. Orbital speed of electron. Velocity is equal to circumference ಆಯ್ತು. Circumference ಅನ್ನ ಒಂದು ಸಲ ಅದು ಕಂಪ್ಲೀಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಇದೇ ಟೈಮ್ ಅನ್ನು ತಗೊಳ್ಬೇಕು. ಅಂದ್ರೆ the analysis is like this. ನನಗಿಲ್ಲಿ ನೋಡುವಾಗ ಪ್ರತಿ t seconds ಗೆ ಒಂದು electrons ಕಾಣ್ತಾ ಉಂಟು ಅಂತಾದ್ರೆ for every t seconds I can see one electron, means I see a charge of 1.602 into 10 to the minus 19 coulombs in a time of t seconds. That means so much of charge completes one full circle in 1 second in the t seconds. Sorry, t seconds ಅಲ್ಲಿ ಒಂದು full circle ಅದು ಕಂಪ್ಲೀಟ್ ಆಗಬೇಕು. ಆವಾಗ velocity equal to one full circle displacement in a time, same time t, because in the same time I come across one electron. So ಆಗಿದ್ರೆ ನಾನು ಇದನ್ನ ಬರ್ಬೇಕೀಗ, because I want to bring this velocity here. Velocity ತರಬೇಕಾದ್ರೆ ನಾನು ಏನ್ ಮಾಡ್ಬೇಕಿಲ್ಲಿ? Velocity into time ಬರ್ಬೇಕಾದ್ರೆ 2 pi r ಬರ್ಬೇಕು. There is no 2 pi r in this equation. A ಇದೆ, of course radius is a. I will multiply and divide by 2 pi r. Correct? ಬೇರೆ ಏನ್ ದಾರಿ ಇಲ್ಲ ಇಲ್ಲಿ. So B is equal to mu naught n. Actually n 1 ಆಗ್ತದೆ because everything is assigned for one circle. Now distance one circle idu, circumference, time one circle. In one circle I find a time of t and I encounter a charge of q. So mu naught n bitbidabodu, let it be there 2a q by t into, what I will do is I will multiply by 2 pi r and divide by 2 pi r. 2 pi a circumference by 2 pi a. Again ಆಗ್ತದೆ, what I'll get. So the equation will be like this. Mu naught B is equal to mu naught n, actually n 1 ಆಯ್ತು, everything is decided for one turn, 2a okay, what is this? 2 pi a can be replaced as
VT.
Yeah, mu naught n by a q by t Vt by 2 pi a. Now you can mix it up. B is equal to mu naught n t qv, t cancel aitala, divided by 4 pi square, 4 pi a square, correct?
Yes, sir. Sir.
Yes. I don't suggest you to by heart this. By heart ಮಾಡೋದು ಬೇಡ, ಯಾಕಂದ್ರೆ this may not be the final formula. ಇದರಲ್ಲೇ ಏನೋ ಗುಣ ಚೇಂಜ್ ಇರಬಹುದು. So see the method in which it is obtained. Current is replaced as charge by time. In the same time, you have to replace the velocity. Velocity is displacement by distance by time. 2 pi r is the distance. In the same time, t it occurs. Aga number of turns 1 ಆಯ್ತು actually. This should be 1. So mu naught qv divided by 4 pi a square. You can get it. ನನಗೆ ಫೈನಲ್ ಫಾರ್ಮುಲಾದಿಂದ ಅದು ಬಂದದ್ದೇನು ಏನ್ ಮಾಡಿದ್ದೇವೆ, that is important because you can't expect the same problem in the final exam. Okay, hope you have understood, right?
Yes, sir.
ಕೊಟ್ರೆ ಸರ್ಕಂಫರೆನ್ಸ್ ಇದರಲ್ಲಿ ಪೀರಿಯಡ್ ಕೂಡ ಕೆಲವು ಸಲ ಕೇಳ್ಬೋದು. ಆಗ ನೀವು ಒಂದು ಫುಲ್ ಸರ್ಕಲ್ ಗೆ ಪೀರಿಯಡ್ ಟಿ ಅಂತ ತಗೊಂಡು ಮಾಡ್ಬೇಕು, ಆಗ ವೆಲಾಸಿಟಿ ಬೇಕಾಗುದಿಲ್ಲ. Okay, fifth one. Yes, it is a cube. Imagine that the room in which you are sitting is made up of a mesh wire in which all the wires pass in the 8 edges of the 8 ಅಲ್ಲ, ಎಷ್ಟು edge ಬರ್ತದೆ, 4 8 12 edges of the cube. ಎಲ್ಲ ವೈರ್ಸ್ ಪಾಸ್ ಮಾಡಿದ್ದಾರೆ ಅಂತ ಇಟ್ಕೊಳ್ಳುವ ರೂಮಿನ ಕಾರ್ನರ್ ಗೆಲ್ಲ. If you pass current, what is the magnetic field at the center of the room? What is the magnetic field at the center of the square? So ಇಲ್ಲಿ ಅಷ್ಟೇ, this magnetic field is cancelled by this one. ಇಲ್ಲಿ ಎರಡು ವೈರ್ಸ್ ಬರ್ತವೆ ನೋಡಿ, they carry current like this. ಒಂದು ಇಲ್ಲಿ ಈ ಕಾರ್ನರ್, ಇನ್ನೊಂದು ಈ ಕಾರ್ನರ್ ರೂಮ್ ಇದ್ದು, ಅದು ದೇ ಪ್ರೊಡ್ಯೂಸ್ ಎ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಇಲ್ಲಿ ನೀವು ಕ್ಲಾಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವಿಲ್ ಬಿ ಲೈಕ್ ದಿಸ್, ಹೀಗೆ ಬರ್ತದೆ. ಅಂಡ್ ಇಫ್ ಯು ಅಪ್ಲೈ ಕ್ಲಾಸ್ ರೂಲ್ ಹಿಯರ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವಿಲ್ ಬಿ, ಅದು ಉಲ್ಟಾ ಬರ್ತದೆ, ಇಲ್ಲಿ ಹೊರಗೆ ಬರುವಾಗ ಹೀಗೆ ಬರ್ತದೆ. ಸೊ ದೇ ಕ್ಯಾನ್ಸಲ್. ಇಲ್ಲಿಂದ ಹೀಗೆ ಹೋಗುವಾಗ ಹೀಗೆ ಬರ್ತದೆ, ಇಲ್ಲಿಂದ ಹೋಗುವಾಗ ಹೀಗೆ ಬರ್ತದೆ. ಸೊ ಯು ಹೋಲ್ಡ್ ದಟ್ ಕಂಡಕ್ಟರ್ ವಿತ್ ಯುವರ್ ರೈಟ್ ಹ್ಯಾಂಡ್. ಸೊ ದೇ ಕ್ಯಾನ್ಸಲ್ ಈಚ್ ಅದರ್ ಹಿಯರ್. ಅದೇ ತರ ಇದು ಮತ್ತು ಇದು ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ತದೆ. So every conductor will cancel the diagonally opposite conductor's magnetic field. Net magnetic field is 0. ಇದರಲ್ಲಿ 0. ಎಲ್ಲವೂ ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ತಾ ಹೋಗ್ತದೆ ಒಂದಕ್ಕೊಂದು. ಇಲ್ಲಿ ಮಿಡ್ಲಿಗೆ ಆಗುವಾಗ, ಬಿಕಾಸ್ ಒನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಪ್ವರ್ಡ್ ಬಂದ್ರೆ ಇನ್ನೊಂದು ಡೌನ್ವರ್ಡ್ ಬರ್ತದೆ. ಸೊ ನೆಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ದ ಸೆಂಟರ್ ಇಸ್ 0. ಕ್ಯೂಬ್ಗೂ ಆಗ್ತದೆ ಅದು, ಸ್ಕ್ವೇರ್ ಮಾತ್ರ ಅಲ್ಲ, ಸರ್ಕಲ್ ಮಾತ್ರ ಅಲ್ಲ. ಓಕೆ, two parallel straight current carrying conductors at the center. So at the center net magnetic field must be 0 because idu ade tara aaytu. Iga idanna ನೀವು ಕ್ಲಾಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ it will be like this. One, yes. Okay, so two straight parallel conductors carrying current. One is here and another is here. So what happens is you have to apply the class rule here. So illinda apply ಮಾಡುವಾಗ when you come to the center ಗೆ ಬರಬೇಕು, ಇದರ ಮಧ್ಯಕ್ಕೆ ಬರಬೇಕು. So ಮಧ್ಯಕ್ಕೆ ಬರುವಾಗ the magnetic field will come like this and it will be into the paper. Due to this one, this current, it is into the paper here. What about this one? When you hold this conductor with your right hand, fingers come out of the paper. Illige into ಹೋಗ್ತದೆ. So these fingers go in here, but they come out here. Illi ಹೊರಗೆ ಬರ್ತದೆ. So they are out of the paper. If the point is exactly at the center, what happens? Magnetic field due to this conductor, they cancel, correct? So net magnetic field at the center is 0. So yeah, this ಈಗ ನೀವು ಕ್ಲಾಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಹೋದ್ರೆ, this conductor will produce a magnetic field. ನೀವು ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ಬೇಕು ಅದು. ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ ದಿಸ್ ಕಮಿಂಗ್ ಔಟ್ ಹಿಯರ್, ಗೋಯಿಂಗ್ ಇನ್ ಹಿಯರ್. ಇದು ಮಾಡೋದು ಇಲ್ಲಿ ಹೀಗೆ ಬರುವಾಗ ಇಟ್ ವಿಲ್ ಬಿ ಲೈಕ್ ದಿಸ್, ಕಮಿಂಗ್ ಔಟ್, ಗೋಯಿಂಗ್ ಇನ್. ನಾವು ನೋಡ್ಬೇಕಾದ್ದು ಇಲ್ಲಿ. ಸೊ ಇಲ್ಲಿ ಕ್ಲಾಶ್ ಶುರು ಆಯ್ತು. ಒನ್ ಇಸ್ ಗೋಯಿಂಗ್ ಇನ್, another is going out. So at the center it is 0. But ಆ ಕಡೆ ಈ ಕಡೆ ಹೋದ್ರೆ there will be difference in the magnetic field. Yes, at the center it is 0. B is 0. Oh, 1 minute. Okay. 7th one. Yeah, at different distances, what you have to do is you have to find out the magnetic field outside. ಈಗ outside ಇದ್ರೆ suppose a conductor carries current and if the point is considered outside both the conductors. So one conductor is carrying current like this, another conductor is carrying current like this. If you select it here, now the magnetic field due to this, if you apply Class rule, it will be like this, like this. So it will be going like this. So it will be going into the paper here. And here also, if you clasp it like this, it will also be going into the paper like this, so they will add up. But distances will be different. For this conductor, it is R, and for this conductor, it is R plus X. So what is the net magnetic field here? It is B1 plus B2. That is mu naught. If they are infinitely long, mu naught by 4 pi, 2I by R. Illi mu naught by 2 pi ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ ಅದನ್ನು. Mu naught by 2 pi, I by R. R change ಆಗ್ತದೆ. 1 by R plus X. ಇದನ್ನ ಇನ್ನೊಂದು 1 by X. ಇದಕ್ಕೆ X. 1 by X plus 1 by R plus X. And it is into the paper. So here the magnetic fields add up. Here also they add up, but direction ulta ಅಷ್ಟೇ ಹೊರಗೆ. Because these circles will go like this. ಇದರದ್ದು ಅಷ್ಟೇ ಹೀಗೆ ಬರ್ತದೆ. So by the time it reaches here, it will be outside. Right? ಇದೆಲ್ಲ ಈಸಿ ಇದೆ. Yes. ಇದು ಆಕ್ಚುಲಿ ವೈರ್ ಹೇಗಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇಟ್ ಇಸ್ ಲೈಕ್ ದಿಸ್. ಕೇಳ್ತಾ ಉಂಟಲ್ಲ, 25 ವೈರ್ ಪಾಸ್ ಆಗಿದೆ ನನ್ನ ಮೇಲಿಂದ, ಅದು ಇದು ಅಂತ ಹೇಳ್ಕೊಂಡು ಕ್ಯಾಮರಾ ಅದು ಇದು ಅಂತ ಯಾವ್ದು ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗ್ತಾ ಗೊತ್ತಿಲ್ಲ ನನಗೆ. ಆಕ್ಚುಲಿ ಇಟ್ ಈಸ್ ಲೈಕ್ ದಿಸ್. ಇದೊಂದು ವೈರ್ and the same wire can be made into a loop like this and then proceeded. ಅಥವಾ ಬೇರೆ loop ಇಟ್ಕೊಳ್ಬಹುದು, no problem. So I have a circular loop and then it is continued like this. What is the magnetic field here? ಹೀಗೂ ಇಟ್ಕೊಳ್ಬಹುದು ಅಥವಾ separate circular loop and a wire like this. What is the magnetic field at the center of the circle? At a distance A from the wire. At a distance A from the wire. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, suppose both the wires are infinitely long. ಇದಕ್ಕೆ ಇದು ಎಡ್ಜ್ ಆಗ್ತದೆ, ಈ ಪಾಯಿಂಟ್, ಇದಕ್ಕೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಡ್ಜ್ ಆಗ್ತದೆ. ಸೊ ಇದಕ್ಕೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಡ್ಜ್, ಇದಕ್ಕೆ ಎಂಡಿಂಗ್ ಎಡ್ಜ್, ಇದು ಪಾಯಿಂಟ್ ಆಲ್ಮೋಸ್ಟ್. So you know that magnetic field at the corner of a magnetic straight wire, infinitely long straight wire, is mu naught by 4 pi I by D. At the center, it is mu naught by 4 pi 2I by D. So this is half that at the center. So if you treat these two conductors as separate, this will produce a magnetic field at the edge. This will produce a magnetic field at the edge. When you add it, it automatically becomes double, which is same as the magnetic field at the center of a single wire, infinitely long. ಅಲ್ವಾ? ಇದು ಇಲ್ಲಿ ಸೇಮ್ ಆಗ್ತದೆ. ಸೊ ನೋ ಚೇಂಜ್. ಸೊ ನಾವೀಗ ಡೈರೆಕ್ಷನ್ ಮಾತ್ರ ನೋಡ್ಬೇಕು. ಸೊ ಕರೆಂಟ್ ಫ್ಲೋಸ್ ಇಲ್ಲಿಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅವ್ರದ್ದು ಉಲ್ಟಾ ಉಂಟು ಕರೆಂಟ್. ದಿಸ್ ಈಸ್ ಅಲ್ಲಿ ತಪ್ಪಿದ ಅಂತದ್ದು. ಹೀಗೆ ಇದೇ ವೈರ್ ಅಂತ ತಗೊಂಡ್ರೆ ಹೀಗೆ ಬರಬೇಕು. ಐ ವಿಲ್ ಟೇಕ್ ದಿಸ್ ಎಕ್ಸಾಂಪಲ್. ನಾ ವಾಟ್ ಅಬೌಟ್ ದಿಸ್ ಕಂಡಕ್ಟರ್? ಹೌ ಡಸ್ ಇಟ್ ಪ್ರೊಡ್ಯೂಸ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ಅದ್ರದ್ದು ಹೇಗಿರ್ತದೆ ಅಂತ. ಸೊ ವಿ ಹ್ಯಾವ್ a wire, ವಿಡಿಯೋದಲ್ಲಿ ಹೇಳ್ತಾ ಇದ್ದೇನೆ, wire, and here you have a circular wire here. ಅದರ ಕರೆಂಟ್ ನಾನು ಹೀಗೆ ತಗೊಂಡಿದ್ದೇನೆ, ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಬೇರೆ ಇದೆ. So let it be like this. So if this is infinitely long like this, separate, its magnetic field is out of the paper due to the straight wire, because you have to hold the straight wire like this with thumb showing the direction of current, right? So it shows outside. ಯಾವ್ದ್ರದ್ದು? ವೈರ್ ಇದು. So wire is outside, correct? What about coil? Inside, correct?
Inside.
Yes, sir.
All fingers show the direction of current and the thumb shows the direction inside. So due to coil it is inside and due to wire it is outside. ಇನ್ನು ಯಾವ್ದ್ರದ್ದು ಸ್ಟ್ರಾಂಗ್ ಅಂತ ನೋಡ್ಕೊಳ್ಬೇಕು, ಮತ್ತೆ ಮೈನಸ್ ಮಾಡ್ಬೇಕು. ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ಸ್ ಆಫ್ ಕೋರ್ಸ್ ಅವ್ರೇನು ನಮಗೆ ರೆಫರೆನ್ಸ್ ಕೊಡ್ಲಿಲ್ಲ ಡೈರೆಕ್ಷನ್ಸ್ಗೆ. ಸೊ ಡ್ಯೂ ಟು ವೈರ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ವೈರ್ ವಿಚ್ ಈಸ್ ಔಟ್ಸೈಡ್. ವೈರ್ ಇದು ಹೀಗೆ ಔಟ್ಸೈಡ್ ಬರಬೇಕು. ಕಾಯಿಲ್ ಇದ್ದು ನೀವು ಇದು ಥಂಬ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಒಳಗಡೆ ಬರಬೇಕು. ಸೊ ದಿಸ್ ಈಸ್ ಡ್ಯೂ ಟು ಕಾಯಿಲ್. BW is mu naught Ni by 2R. Sorry, wire ಇಂದಾಗಿ mu naught by 4 pi I by 2I by distance A. ಸೆಂಟರ್ ಅಂತ ತಗೊಳ್ಳುವ. ಅಫ್ಕೋರ್ಸ್ ನೀವು ಇದಕ್ಕೆ ಮಾತ್ರ ಬರೆದ್ರೆ mu naught by 4 pi I by A. ಇದರದ್ದು μ0/4πi/a ಆಡ್ ಆಗ್ತದೆ. 2i/a ಬಂತು. ಇದನ್ನು ಸಿಂಗಲ್ ವೈರ್ ಅಂತ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿಯೂ ಕರೆಂಟ್ ನಾನು ಹೀಗೆ ತಗೊಂಡಿದ್ದೇನೆ. ಕಾಯಿಲ್ ಅನ್ನು ಸಪರೇಟ್ ತಗೊಂಡ್ರು. What is the magnetic field due to the coil? Magnetic field due to the coil is μ0 n 1 turn I by 2 times radius. Correct?
Yes, sir.
ಇಲ್ಲಿ 2 ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಕೊಳ್ಳುವ ಬಿಕಾಸ್ ನಾವು ಆಪ್ಷನ್ ಇಲ್ಲಿ ಆನ್ಸರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ದೇ ವಾಂಟ್ ಟು ರೈಟ್ ಇಟ್ ಇನ್ ಬೈ 2 ಅಲ್ಲಿ ಬರೀಲಿಕ್ಕೆ ಅವರಿಗೆ. ಸೊ ದಿಸ್ ಗೆಟ್ಸ್ ಕ್ಯಾನ್ಸಲ್ 2. ಸೊ ಇಲ್ಲಿ ಇವಾಗ ಆಕ್ಚುಲಿ ವಿ ಹ್ಯಾವ್ ಟು ಸಬ್ಟ್ರಾಕ್ಟ್, ಬಟ್ ಅವ್ರು ಕೊಟ್ಟ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಓಕೆ ಕರೆಕ್ಟ್ ಆಡ್ ಮಾಡ್ಬೇಕು. ಇದನ್ನೇ this current is clockwise, so its magnetic field is outside, as same as the wire, alwa. So our their diagram is like this. Wire is carrying current in the clockwise direction like this, and this is carrying current in this direction. So avaga this will be outside and this will be outside. Am I right? Due to wire, it is outside, and this is also outside. Coil kuda outside. Sari alla. So add ಮಾಡ್ಬೇಕು. ಅವರ ಪ್ರಕಾರ add ಮಾಡ್ಬೇಕು. So ಈಗ ನಾನು ಮಾಡಿದ ಡಯಾಗ್ರಾಮ್ ಪ್ರಕಾರ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. So which is larger in this? ನೀವು ಎರಡು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ಬರೆದ್ರೆ which is larger?
Wire.
E due to wire is μ0 by ಕಾಮನ್ ಟರ್ಮ್ಸ್ ಉಂಟಲ್ಲ ಇಲ್ಲಿ μ0 I by 2a, ಇಲ್ಲಿ 1/pi. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ದ ಕಾಯಿಲ್ ಇಸ್ μ0 I by 2a, ರೈಟ್? ಇಲ್ಲಿ ಒಂದು ಪೈ ಜಾಸ್ತಿ ಬರ್ತದೆ. ಸೊ BW, ವ್ಯೂ ಡ್ಯೂ ಟು ವೈರ್ ಇಸ್ ಲೆಸ್ ದನ್ ವ್ಯೂ ಡ್ಯೂ ಟು ಕಾಯಿಲ್, ರೈಟ್? ಇದೊಂದು ಪೈ ಎಕ್ಸ್ಟ್ರಾ ಬರ್ತಲ್ಲ. ಸೊ ಹಾಗಿದ್ರೆ ಈಗ ನಮ್ಮ ಇದಕ್ಕೆ ಬರಿಬೇಕಾದ್ರೆ ದ ನೆಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ μ0 I by 2a into this one 1 minus 1/pi, correct?
Yes, sir.
Because this is smaller. By pi ಮಾಡುವ ಕಡಿಮೆ ಆಗ್ತದೆ ಅದು, ರೈಟ್? ಬಟ್ ಇಲ್ಲಿ 1 plus 1/pi ಬರ್ತಿದ್ದಾರೆ ಬಿಕಾಸ್ ದೇ ಆರ್ ಇದು ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ ಡೈರೆಕ್ಷನ್. ಓಕೆ, ಯಾವುದು ಬಯಾಟು ಇರ್ಲಿಕ್ಕಿಲ್ಲ ಫಾರ್ಮುಲಾಸ್ ಎಕ್ಸೆಪ್ಟ್ ಫಸ್ಟ್ ಹೇಳಿದ ಇದು. ಇಲ್ಲಿ ಎಸ್, ಹಿಯರ್ ದೇ ಹ್ಯಾವ್ ರಿಟರ್ನ್ ದಟ್, ರೈಟ್? ಸರಿ ಉಂಟು ಈಗ ದ ಸೇಮ್ ವೈರ್. ಓಕೆ, ಹಾಗಾದ್ರೆ ಇದು ಎರಡು ಬೇರೆ ಬೇರೆ ಪ್ರಾಬ್ಲಮ್. ಐ ಹ್ಯಾವಂಟ್ ಸೀನ್ ಇಟ್ ಪ್ರಾಪರ್ಲಿ. ಇದು ನಾವು ಇದನ್ನು ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ತಗೊಂಡಾಗ ಆಯ್ತು. ದಿಸ್ ಈಸ್ ಎ ಸಪರೇಟ್ ಕಾಯಿಲ್ ಅಂಡ್ ದಿಸ್ ಈಸ್ ಎ ವೈರ್. ಬಟ್ ಅದೇ ಕಾಯಿಲ್ ಅನ್ನ ಈಗ ನೀವು ಅದೇ ವೈರ್ ಅನ್ನ ಕಾಯಿಲ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಯು ಕಾಂಟ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಕರೆಂಟ್ ಲೈಕ್ ದಿಸ್ ಇನ್ ದಿಸ್ ವೈರ್. ಹೀಗೆ ಹೋಗ್ಬೇಕು. ಸೊ ಹಿಯರ್ ದೇ ಹ್ಯಾವ್ ಸಬ್ಟ್ರಾಕ್ಟೆಡ್. ದಿಸ್ ಈಸ್ ಕರೆಕ್ಟ್. ಮತ್ತೆ ಇದನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೇಕಾಗಿಲ್ಲ. ಎಸ್, ಹಾ, ಅದು ಸೇಮ್ ಆಯ್ತು. ಆಗತ್ತೆ ಯು ಆರ್ ಸಿಲೆಕ್ಟಿಂಗ್ ಸ್ಟ್ರೈಟ್ ವೈರ್ ಅಂಡ್ ಲೂಪ್ಸ್ ಅಟ್ ದ ಸೆಂಟರ್. ಇದು ಆಕ್ಚುಲಿ ರಾಂಗ್ ಆಯ್ತಲ್ಲ. Here should be current like this, right? It should get divided into 2 and again join, right?
Yes,
magnetic
sir.
field is 0. Now it is 0. So you are selecting the 2 end points of a wire and passing current like this. So it gets divided into I by 2 and I by 2 and then passes like this. So in the correction of V0, we know it. Then 11, yes. Semicircular arc of a wire. Half. ಈಗ ಇಂಥದ್ರಲ್ಲೆಲ್ಲ ಮಾಡುವಾಗ so it is like this and the wire carries, and this is from infinity, this is towards infinity, like this. Current is like this, like this, like this. Now whenever you take a conductor and find out the magnetic field along its direction, along the current element direction, here there is no magnetic field. Magnetic field is always found in a plane perpendicular to the plane of the conductor and in the form of concentric circles, but there are no magnetic field along the wire. ನೀವು ಈ ಫಾರ್ಮುಲಾ ಅನ್ನು ತಗೊಂಡು ಬಂದ್ರು ಕೂಡ, ಸಪೋಸ್ ಇಟ್ ಈಸ್ ಎ ಫೈನೈಟ್ ಲೆಂತ್ ಅಂತ ತಗೊಂಡ್ರು ಕೂಡ, ಈ phi1 and phi2 μ0 by 4pi I by d into sin phi1 plus sin phi2 ಅಂತ ಬರೀತೀವಲ್ಲ. when you shift this point here, sin phi1 sin phi2 both become 0, right?
Yes, sir.
When you shift the point to the along the wire, suppose the wire carries a current of I, when you shift the point along the wire, sin phi1 becomes 0, sin phi2 becomes 0. So no magnetic field along the wire. ಅದಕ್ಕೆ ಇನ್ನೊಂದು ಹೇಳಲಿಕ್ಕೆ ಆಗ್ತದೆ. ಹೇಗೆ ಅಂದ್ರೆ It is like this. Oh, illi untala. Biot-Savart's law. Yeah. This is the element. Idu element. So along the element, if you select a point, now the point is somewhere outside the element. So idರಲ್ಲಿ current hige ಮೇಲೆ ಹೋದ್ರೆ magnetic field will be like this in the form of circles here. Now if you select the point here, this theta becomes 0, right? When theta becomes 0, everything becomes 0. Mu naught by 4 pi ideal sin theta by r squared. So along the wire, along the element, there is no magnetic field always. So avaga ನಾವು ಎಲ್ಲಿಗೆ ಬಂದ್ವಿ? Yes, 0, right. Yes. Yes, we are here. So no magnetic field is produced. I will name this 1, 2, 3. No magnetic field is produced at the center O. I'm finding the magnetic field at the center of the arc. No contribution from this. No contribution from this here, because they produce zero magnetic field along their line. Correct? Only arc
Yes,
will
sir.
produce a magnetic field, right? Arc matra produce ಮಾಡ್ತದೆ, and its radius is given. What is the magnetic field at the center of the arc? B is equal to mu naught Ni by 2r. Now N is half, right? Mu naught half
Yes.
I by 2r. So mu naught I by 4r. Of course, ಇಲ್ಲಿ minus ಅವರು mostly outside direction ಅನ್ನ positive ತಗೊಂಡಿರ್ಬೇಕು. That's why they have written minus. That's all, nothing else. Outside the line coming outside the paper is taken as a z axis. Inside aga ಇದು inside ಬರ್ತದಲ್ಲ, it is like this inside. So inside ಬರುವಾಗ ಅದು minus k cap ಅಂತ ಏನೋ ತಗೊಂಡಿರ್ಬೋದು. Then nothing more in that. Okay. Then hope you have understood this. We'll move.
Yes, sir.
Right. Semicircular arc at the center of the arc. Okay. ಇದು ಮತ್ತೆ ಅದೇ, ಅದು ಆರ್ಕ್ ಕೆಳಗೆ ಬಂದಿದೆ ಅಷ್ಟೇ, ಅದರಲ್ಲಿ ಮತ್ತೆ ಏನು ಮಾತಾಡ್ಲಿಕ್ಕಿಲ್ಲ. ಸೇಮ್. Right. Now if the coil is like this, ಒಂದು separate coil ಮಾಡಿದ್ದಾರೆ ಅವರು ಎರಡು. So one coil is like this, and here the battery is connected, and another coil comes like this. Center is same for both. Both are half turns, and the current flows like this from positive to negative. ಹೋಗ್ಬೇಕಲ್ಲ, ಇಲ್ಲಿ battery ಉಲ್ಟಾ ಉಂಟು. Battery is like this. Here is negative and here is positive. So current flows like this, like this, like this. So right. So this part of the wire and this part of the wire, they don't contribute because this point lies along with these wires. E wires ಗೆ ಏನು ಕೆಲಸ ಇಲ್ಲ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಮಾಡೋದು. They will produce a magnetic field here. ಇಲ್ಲೆಲ್ಲ ಮಾಡ್ತದೆ, but along the wire they don't produce any magnetic field. So due to this part it is cancelled. So no contribution from this part. No B and no B. No B andre no magnetic field here, right? No B at O. Not everywhere. They will produce a magnetic field around their region, but not at O. So what is the magnetic field at O? E circle idu ಮತ್ತು E circle idu. And remember in the formula, general formula, mu naught Ni by 2r. R is different. Number of turns constant, ಎರಡಕ್ಕೂ half. Current same, constant. ಹಾಗಾದ್ರೆ one which decides the stronger field is R. R1 and R2. R1 is smaller. So ಆಮೇಲೆ whether they add up, magnetic field add up. ಯಾಕಂದ್ರೆ ಅದು ಹೇಗೆ ಕಾಯಿಲ್ ಹೀಗಿದ್ರು, it is like a circle, right? It is like this. So here is one coil. Sorry, ಬೇರೆ ಮಾಡು. So here is one part and change one. So here is one part and here is another part. Current is like this, like this, like this, like this. So everything is like this current. ಎಲ್ಲವೂ ಹೀಗೆ ಉಂಟು. So what happens? Magnetic field at the center should be in single direction, both. So add ಮಾಡಿದ್ರೆ ಆಯ್ತು ಎರಡನ್ನು. So you have to add the magnetic fields. So everything which is constant, you can take it outside. Mu naught, half turn, ಆಮೇಲೆ I, y2, everything is constant, 1 by r1 plus 1 by r2. If it was in opposite direction, 1 by r1 minus 1 by r2. So mu naught I by 4 into 1 by r1 plus 1 by r2. And depending on the situation, ಯಾವುದು ಆಪ್ಷನ್ಸ್ ಹೇಗಿದೆ ಅದು ಸರಿಯಾಗಿ ಮತ್ತೆ ಚೇಂಜಸ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೇಕು. ಕೆಲವು ಸಲ ಪೈ ಬೇಕಾಗ್ಬೋದು ಅವರಿಗೆ, ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ ಬೈ 5. ಸೊ ಯು ಕ್ಯಾನ್ ಚೇಂಜ್ ಇಟ್ 14. ಎಸ್, ಇದು ನಾವು ಆಗ ಮಾಡಿದ್ದೇವಲ್ಲ, ಸೇಮ್ ಕಾನ್ಸೆಪ್ಟ್. ನಾವು ಹೀಗೆ ಮಾಡಿದ್ದು. We have proved it in 2 ways. One by taking Biot-Savart's law, another by taking the magnetic field due to arc of a circle, that is a circular coil. Mu naught by 4 pi I theta by r. Right? R is the radius. Idu sin 90 ಆಗುತ್ತೆ. Biot-Savart's law ದಲ್ಲಿ mu naught by 4 pi I dl sin theta by r square. dl ಅನ್ನ r d theta ಅಂತ ಹಾಕೊಂಡ್ರೆ ಒಂದು r ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ r square ಇದರಲ್ಲಿ. So this is the magnetic field at the center. Already we have proved it, right? ಇಲ್ಲಿ alpha ತಗೊಂಡಿದ್ದಾರೆ. Of course, you can project the coil outside. ಇನ್ನೂ ಇದು ಮಾಡಬಹುದು. But you must take the angle within the coil. Outside the coil angle ಆಗುದಿಲ್ಲ. Within the coil ಬೇಕು. The angle subtended at the center by the coil, not outside part. Okay. 15. Yes. ಇದು actually ಹೇಗೆ ಉಂಟು ಅಂತ ಹೇಳಿದ್ರೆ ಹೀಗೆ ಉಂಟಿದು. There is a part of the coil. So ಇನ್ನು ಮುಂದೆ ಇದರಲ್ಲಿ ಯಾವ ಟೈಪ್ ಪ್ರಾಬ್ಲಮ್ ಬಂದರೂ ನೀವು ಮಾಡಬೇಕು. It is like this. ಹೀಗೊಂದು ಏನೋ ಮಾಡಿದ್ದಾರೆ. ಎಲ್ಲೋ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡಿರ್ಬೋದು, need not worry. And these are all dotted lines, and they make an arc of circle of angle theta. The current is made to pass like this. Battery ತೋರಿಸಲಿಲ್ಲ, ಎಲ್ಲೋ ಒಂದು ಕಡೆ ಬ್ಯಾಟರಿ ಇರಬೇಕು. So same current passes through all the parts. I. Like this. Now, I ಬಗ್ಗೆ worry ಇಲ್ಲ ನಮಗೆ. And remember, this is R1. ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. This part is only having radius R1. This part is having radius R2. Upper coil. Now there is no contribution from this. No contribution. ಎಲ್ಲಿ magnetic field at the center. ಈ part ಉಂಟಲ್ಲ, this part of the wire and this part of the wire, they don't contribute to any magnetic field here. O. Because they are along the point O. If you produce them backwards or forward, you don't get, you find the point to be along the line of the wire itself. So no magnetic field at the O. Not possible. Only these arcs will contribute. You know what is the magnetic field produced by an arc of a circle? B is equal to mu naught by 4 pi I theta by r. So only variables you take it inside the bracket. And remember, this is clockwise, this is anti-clockwise. ಹಾಗಿದ್ರೆ ಒಂದು ಮತ್ತೊಂದಕ್ಕೆ ಉಲ್ಟಾ ಇರಬೇಕು. And remember, ಈಗ ಸ್ವಲ್ಪ ಪಾಯಿಂಟ್ಸ್ ಗೊತ್ತಾಯ್ತು. One which has got lesser radius will produce the stronger field. So lesser radius first ಗೆ ಹಾಕೋಬೇಕು. It is outside, and the upper one is inside. So ಹೀಗಿದೆ. So like this. So this is like this. This is like this. So upper one ನಿಮಗೆ ಇದು ಇಂಟು ಮಾಡಿದ್ರೆ lower one will produce outside. Correct? ಹೀಗೆ ಬರ್ತದೆ. Thumb will be coming outside. Upper one ಹೀಗೆ ಬರ್ತದೆ magnetic field. So totally you have to subtract them. They are not added. So the net magnetic field is constants ಅನ್ನೆಲ್ಲ ತರುವ. Both the arcs make an angle theta. Mu naught I same theta by 4 pi. Only difference is in R1 and R2. ಆಮೇಲೆ ಡೈರೆಕ್ಷನ್ ಆಫ್ R1 ನಾವು ಕೊಡ್ಬೇಕು, ಯಾಕಂದ್ರೆ ಅದು ಸ್ಟ್ರಾಂಗರ್ ಅಲ್ಲ. That remains finally. Magnetic field na direction produced by I, that is outside, ಅದು ಕೊಡ್ಬೇಕಾಗ್ತದೆ. K cap, J cap, ಅದು ಒಂದಷ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ, ಅದು ಮತ್ತೆ ಮಾಡ್ತಾ ಹೋಗುವ. Hope I can move.
Yes, sir.
Okay, 16. So the same type, only one angle is given. The diagram ಕಾಣದೇ ಇದ್ರೆ it is like this. So here is some part of the coil and it makes an angle at the center. So ಇಲ್ಲಿಂದ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡಿ ಇಲ್ಲಿಗೆ ತಂದು ಮತ್ತೊಂದು ಪಾರ್ಟ್ ಆಫ್ ದ ಕಾಯಿಲ್ ಮಾಡಿದ್ದಾರೆ, ಮತ್ತೆ ಇಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. Same current flows I like this. They want the magnetic field at the center here. So this part of the wire, this part of the wire, they don't contribute anything. because the point where we are finding the magnetic field is along the line. So like this. Oh, ಉಲ್ಟಾ ಆಯ್ತಲ್ಲ, ಇದನ್ನ ಪ್ಲಸ್ ಮಾಡುವ, ಸರಿ ಆಗ್ತದೆ ಆಗ. ಅಲ್ಲಿರುವುದು ಹಾಗೆ. Yes, this is plus to minus. Okay. So inner coil is ಇಲ್ಲಿ angle ಯಾವ್ದು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅವರು alpha. Yeah, this is given as alpha. ಇದನ್ನು dotted line ಮಾಡಿ. This is given as alpha. Remember, this is not the angle that we need. 2 pi minus alpha is the angle that we need. Angle made by the coil at the center. So, and you know, what the previous problem is there. This is R1, one the R1 on the R2. So this is R1 and this is R2. Mu naught I theta, mu naught by 4 pi, I theta by R. Mu naught by 4 pi, I theta ಎರಡಕ್ಕೂ ಒಂದೇ angle same. ಅವ್ರ ಹೊರಗಿನ angle ಕೊಟ್ಟದ್ದು 2 pi minus alpha 1 by R1 minus 1 by R2. ಸರಿಯಲ್ಲ?
Yes, sir.
Yes, sir.
Okay. ಇದು ಅಂತದೆ. ಇದರಲ್ಲಿ ಒಂದು ಆಲ್ಫಾ ಇನ್ನೊಂದು ಇದು ಕೊಟ್ಟಿದ್ದಾರೆ. So the coil is like this. So here is a battery and here is an arc of a circle and it comes over here and then forms another circle like this, and they give the angle. So ಇದು ಎರಡು ಕೂಡ they make angle same at the, sorry, they have the same center ಎರಡಕ್ಕೂ same. So it is like this. Yeah, both have the same center. ಇದನ್ನು ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡುವಾಗ ಇಲ್ಲಿಗೆ ಬರಬೇಕು. And the angle, this alpha is given. For this coil it may be alpha. Here the current flows like this. ಇಲ್ಲಿ positive ಇಂದ ಹೊರಡಬೇಕು, like this, like this. So this is the I. Current is same everywhere, but only the thing is angle alpha. ಇದಕ್ಕೆ alpha ಆದ್ರೆ ಇದಕ್ಕೆ 2 pi minus alpha ಆಯ್ತು. So same angle ಬರುವುದಿಲ್ಲ. Last time they were on the same side. ಒಂದೇ side ಅಲ್ಲಿ ಇತ್ತು, alpha same ಬಂತು ಎರಡಕ್ಕೂ. Sorry, 2 pi minus alpha was the angle subtended at the center by both the arcs, but here it is not the same. So ಇದಕ್ಕೆ ಬೇರೆ angle alpha ಬರ್ತದೆ. For this one, is the different angle 2 pi minus alpha bರ್ತದೆ. So I can change the color and I can mark it here. This is 2 pi minus alpha. Angles are subtended by this 2 pi minus alpha. And R1 and R2 ಅಲ್ಲಿ difference ಇದೆ. You can see that here. R1 ಇದು R2 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. This radius is R2. ಇದರದ್ದು R1. So ಅವಾಗ R1 ಜಾಸ್ತಿ ಇರಬೇಕು, ಸ್ಟ್ರಾಂಗರ್ ಇರಬೇಕು. That okay, you can't conclude which is stronger and which is weaker because the number of turns ಕೂಡ ಇಲ್ಲಿ different ಇದೆ. Theta is different. So what is the net magnetic field? But they are coming carrying current in the same direction. ಎರಡು ಕೂಡ it is clockwise, so they should produce the same direction magnetic field. Mu naught, so B naught, mu naught by 4 pi I theta common ತೆಗಿಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. R2 ಗೆ theta is alpha by R2 plus ಇದಕ್ಕೆ 2 pi minus alpha I theta by R1. Is it right?
Yes, sir.
Sir.
Yes. Okay. 18. A long pin in the sense it is like this. Infinitely long and an arc again infinitely long. So that this will be the radius of this arc, R radius. So for this infinitely long wire, oil in the start ಮಾಡಿದ್ರೆ this becomes the edge. For this infinitely long wire, this becomes the edge. ಅದು R ಆಗಬೇಕು ಎರಡು, because it is the arc of a circle. It's like this. But directions ನೋಡ್ಕೊಳ್ಬೇಕು ಈಗ. Current direction is like this here. Now this is the edge of an infinitely long wire. So ಇದನ್ನು parts ಮಾಡುವ. We will name them as 1, 2, 3 because there are two conductors, infinitely long conductors, and one circular coil, half circle. So this is 1, this is 2, and this is 3. For this one, apply the clasp rule. ಹೇಗೆ ಬರಬೇಕು magnetic field? So when I hold the thumb with the direction of current and hold the whole conductor, the fingers should come out one in the, am I right?
Yes, sir.
Fingers should come out.
Yes, sir.
So it is like this. This is current like this, and this is the arc of the circle and carrying current like this. So when I hold this, idanna nan hege hold madbeku andre hege hold madbeku. Isn't it? Current should be in this direction. So they come outward really. So due to one, it is out. This, what about this one? This is carrying current like this. Hege current kalista untadu. If it is carrying current like this, I have to hold the fingers like this. This is also coming out, right?
Yes, sir.
So 2 is also out. What about 3? This is a conductor carrying current in this direction. So I have to hold it like this. So it is also carrying out, right?
Yes, sir.
All the 3 must be added. Oh, right? So
Yes, sir.
B is equal to B naught at the center. Oh. B1 plus B2 plus B3. B naught is equal to B1. That is magnetic field at the edge of a wire, infinitely long wire. Mu naught by 4 pi I by D, I by R illi. Plus, ಇನ್ನೊಂದು ಹಂತದೇ ಬರ್ತದೆ ಇದ್ರದ್ದು. Mu naught by 4 pi I by R. ಯಾಕಂದ್ರೆ ಅದು ಹಾಗೆ ಅಲ್ವಾ, ಡೈರೆಕ್ಷನ್ ಅದೇ, it will produce a magnetic field outside. So mu naught by 4 pi I by R. Then what about this one? R capacity, mu naught Ni by 2R, correct? Mu
Yes,
naught N is half I by twice the radius. N ಒಂದು ಮಾತ್ರ ಅಲ್ವಾ? N is half,
Yes, sir.
or half of the circle. Mu naught Ni by 2R. So what is the magnetic field at the center? B naught is equal to mu naught pi. ನಮ್ಗೆ ಒಳಗಡೆ ಇಲ್ಲಿ ಅವರು ಇಲ್ಲಿ ಇದನ್ನು ಈ ತರ ಬರಿಬೇಕು ಅಂತಾದ್ರೆ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಪೈ ಬರಬೇಕು. ಇಲ್ಲಿ ಪೈ ಇಲ್ಲ. So multiply and divide by pi, right? Pi. ಇದು ನನ್ನದು ಎಕ್ಸ್ಟ್ರಾ ಫಿಟ್ಟಿಂಗ್. ಬಿಕಾಸ್ ಇನ್ ಆರ್ಡರ್ ಟು ಹ್ಯಾವ್ ದ, ಇದೀಗ ಆಪ್ಷನ್ಸ್ ನೋಡುವ ಗೊತ್ತಾಗ್ತದೆ ಅಲ್ಲ. ಈಗ ಇಲ್ಲಿ pi minus 2, 2 pi plus 1 ಹಾಗೆಲ್ಲ ಇರ್ತದೆ. ಬಟ್ ದಿಸ್ ಕಾಮನ್ ಎಲ್ಲದರಲ್ಲಿ ಇರ್ತದೆ. ಸೊ ದೇ ವಾಂಟ್ pi outside. Mu naught by 4 pi. ಆಮೇಲೆ ಏನ್ ತೆಗಿಬಹುದು? I by R can be taken out, right? I by R, right? Into
1 plus 1 plus
1 plus ಇಲ್ಲಿ ಒಂದು pi ಬರ್ತದೆ. Pi plus 1, correct? That
Yes,
means 2
sir.
plus pi. So mu naught by 4 pi I by R 2 plus pi. That is the magnetic field at the center. Okay,
yes, sir.
right. A wire like this. Okay, here you have a straight wire, and then a circular wire here, and infinitely long. Idu kuda infinitely long anta tagobeko. This is also infinitely long. So current is going out like this. Here it is entering, here it is entering, and this point is the point where I want to find out the magnetic field at having a radius R. Aga idu kuda idagtade R, and this is an infinitely long wire with its edge at the point O, and this is the center of the circle, half circle, half anta tagobeka adana, and this is a straight long wire. I think this wire doesn't contribute, right? Correct,
Yes, sir.
Yake it doesn't contribute to any magnetic field along its length. So this comes along its length. Adradu contribution illa. Only this contributes and this one. Idike length alli barudilla, side alli bartade. And what about the direction? What about the direction of the
Outside.
magnetic field? Yes.
Outside.
So it is like this. Wire like this. Amelele. So no contribution of this, since this point lies here. So idralli current hige, and the current in this is like this. So this conductor has to be clasped like this. Hige clasp ಮಾಡಬೇಕು, ಯಾಕಂದ್ರೆ current is in this direction. ಹೀಗೆ. So that shows inside, right?
Yes,
So
sir.
into. This shows into. ಅದು ಒಳಗೆ ತೋರಿಸಿದೆ. What about this wire? Wire ನಲ್ಲಿ ನಮ್ಮ fingers should show the direction of current like this. And the finger shows, the thumb shows inside. Am I right? So hege bantu. So this is inside. So both will produce inside. Am I right?
Yes, sir.
So what is the magnetic field at the center O due to this part of the wire? It is into. This part of the wire is also into. So that is the net magnetic field is B1, then 1, is 2, is 3 into the B1 plus B2 plus B3. 3 has no contribution. B is equal to B1 mu naught by 4 pi I by D. 2I by D adre center, edge adre I by R, I by D. Plus magnetic field due to a half circle, mu naught N I by 2R plus 0. They don't want pi now outside. No, pi beda ante. Pi beda andre pi annu olaga tagondu hogo. 4 ide. Mu naught by 4 I by R common sigutte. So magnetic field at the center 4. Mu naught by 4 I by R into 1 by pi plus 1. Yes. Correct?
Yes, sir.
Right. Square. Answer is
Zero.
it is 0 because whether it is a circle or a loop, whatever it is, current Ni product is the same. So answer is same. Yes. See the questions for the magnetic field at O. For the following questions, what is the magnetic field? Yes. Find the magnetic field at O for the following questions. Ella current same hege bandide, and here they have given I, J, K. K is coming out of the board. I and J upwards. I right side. So now ಏನು ಮಾಡುವ ಇಲ್ಲಿಗ no contribution from this, right? Because this
Yes,
point
sir.
is along the wire. No contribution. So, or I can write it as 1, 2, 3. And how will be the direction? Direction hegide? Whether they will add up or subtract, adu namge
Add up.
they will add up. Just now we did it one. Adre ಸ್ವಲ್ಪ different ಆಗಿತ್ತು ಅಷ್ಟೇ. So it is like this. It was higide. So this coil is like this and coming like this. Current moving like this, like this. So here I want. So this is this part of the wire, circular part of the wire. So it is like this. Higide. So it is into. What about this part of the conductor? Adanne hege idkobeku? I told it like this, right? Adanne hege ತೋರಿಸಿದ್ದು ನಾನು ಇಲ್ಲಿ? Yes, I told it like this. ಹೀಗೆ ಅಥವಾ to show the current. ಹೀಗೆ ಇಡಬಹುದು ನಾನು. The fingers come inside. ಇಲ್ಲಿಗೆ ಬರುವಾಗ inside ಬರ್ತದೆ. Because the current is moving down. When I hold it like this, ಈ fingers ಇಲ್ಲಿಗೆ ಬರುವಾಗ ಒಳಗಡೆ ಬರ್ತದೆ. So it shows into. Both should be added. So what is the net magnetic field? B is equal to B1 plus B2 plus B3. B1 is 0 plus B2 mu naught. ಇದನ್ನ magnetic field vector ಹಾಕುವ. Mu naught Ni by 2R. Mu naught Ni by 2A. I same. And what is this direction? Into. Into means ಇಲ್ಲಿ minus K cap ಆಯ್ತು. Am I right?
Yes, sir.
Plus,
Sir.
because K is outside our plus B3, that is due to a straight wire, mu naught by 4 pi I by D. I by D is a again minus K cap. So totally minus K cap ಆಗಬೇಕು. Minus ಎರಡು ಆನ್ಸರ್ ಇದೆ, ಒಂದು ಇದು ಮೂರು ಆನ್ಸರ್ ಇದೆ. Okay, you have to do that. B naught is equal to mu naught by 4 pi I by A common. ಎಲ್ಲದರಲ್ಲಿ mu naught by 4 pi I by A common. Mu naught by 4 pi ಬರ್ಬೇಕಾದ್ರೆ you have to multiply and divide by pi. ಬೇರೆ ದಾರಿ ಇಲ್ಲ ಫಸ್ಟ್ ಇಕ್ವೇಶನ್ ಗೆ, because it has no pi. ಇಲ್ಲಿ ಯಾವ ಪೈಗಳು ಇಲ್ಲ. pi pi. Yes, mu naught by 4 pi I by A into ಇಲ್ಲಿ ಒಂದು pi ಬರ್ತದೆ. pi
Minus 1.
ಇಲ್ಲಿ 1. Correct?
Yes, sir.
Plus 1 into K cap minus both.
Minus.
Mu naught by 4 pi I by A. Pi plus 1 ಅಲ್ಲ?
Yes, sir. Pi plus 1.
Pi plus 1 into K cap minus ಯಾವ್ದಾಗ್ತದಪ್ಪ?
Second option. option.
ಇದೆಂತಾಗಿತ್ತು ಇದು ಜೆ ಕ್ಯಾಪ್ ಉಂಟು. ಎಸ್. ಓ ವಿ ಕುಡ್ ಹ್ಯಾವ್ ಸಾಲ್ವ್ಡ್ ಇಟ್ ಹಿಯರ್ ಓನ್ಲಿ, ರೈಟ್? ಇದು ಪ್ಲಸ್ ಇದೆ, ಇದು ಮೈನಸ್ ಇದೆ, ಕೆ ಕ್ಯಾಪ್ ಇರೋದು ಒಂದೇ, ಮೈನಸ್ ಕೆ ಕ್ಯಾಪ್. ಇದು ಜೆ ಕ್ಯಾಪ್ ಉಂಟಲ್ಲ. However, this is wrong. This cannot be the magnetic field direct. This is the only one minus with k cap, right?
Yes, sir.
Jump ಮಾಡ್ಬೋದು ಅಲ್ಲಿ. Yes. What about this? This we have done once. Directly ಬರೆಯುವ. So I'll divide this 1, 2, 3. I think all of them will add up, right? ಹಾಗಂತ ತೋರಿಸ್ತೇವಲ್ಲ. This one will be outside and this one will be outside. This one will be outside. So finally k cap should survive. Plus k cap ಆಗಬೇಕು. I think this is the answer, right?
Yes, sir.
ಚೆಕ್ ಮಾಡಿ. ಒಂದ್ಸಲ ಮಾಡಿದ್ವಿ ಅಲ್ಲ. We did it once, okay? Okay, then third one. Yes, ಇದು ಒಂದ್ಸರಿ ಮಾಡಿದ್ವಿ ನಾವು. I think here we will see the direction and we will check it and then you do it yourself. So current is like this. ಹೀಗೆ ಕರೆಂಟ್ ಇದ್ರೆ, so this is like this, outside, this is inside, this is outside. ಈಗ ಎಲ್ಲಿ ಮಾಡೋದು ಒಳ್ಳೇದು ನಾವು? Yes, I'll divide it into 1, second part, third part. B is equal to B0 plus B1 plus B2. Sorry, B0 is equal to B1 plus B2 plus B3. B0 is equal to B1 mu naught by 4 pi I by A, because this distance is A, radius alvada.
Yes,
This
sir.
is at the side. And what is k cap and the j cap? It is outside, right? Hige bartade adu. It is coming outside like this. Am I right?
Yes, sir.
Coming outside means k cap only. Sariyalla? Plus B2, that is going in. Adu hige bartade. It comes like this. It is going in. So going in means mu naught by 4 pi.
Minus k cap.
Yes. ಅದು ಫುಲ್ ಟರ್ನ್ ಅಂತ ಕೊಡ್ಬೇಕಾ? mu naught by 4 pi ಬರೋದಿಲ್ಲ. mu naught ni by 2r. Because it's a circular coil. mu naught ni by 2r, mu naught ni by 2a. ಅಲ್ಲಿ ಪೈ ಬೇಕಾದ್ರೆ ನಾವು ತಗೋ ಬರ್ಬೇಕು. s minus k cap plus again wire ಇದೆ ಬರುತ್ತೆ. mu naught by 4 pi I by a into k cap. Okay. So B naught is equal to, I think we have to, mu naught by 4 pi I by a ಎಲ್ಲ ಕಡೆ ತಗೊಂಡು ಬಂದಿದ್ದಾರೆ ಅವರು ಹೊರಗಡೆ. So I will multiply, ಇಲ್ಲಿ 2 pi ಇಂದ multiply ಮಾಡಬೇಕಾಗತ್ತೆ. Isn't it?
Yes, sir.
2 pi multiply, 2 pi divide. Otherwise you don't get 4 pi. Mu naught by 4 pi I by a k cap last ಗೆ ಹಾಕೋಣ. mu naught by 4 pi I by a into this becomes 2 times, right? Okay, 1 minus, what is this? mu naught
2
by
pi.
4 pi I by a into 2 pi, right? 2 pi ಒಂದು extra ಬರ್ತದೆ ಇಲ್ಲಿ. 2 pi, ಸರಿನಾ?
Yes, sir.
Plus
Plus 1.
1. Yes, sir.
k cap. ಈ ಮೈನಸ್ ಕೆ ಕ್ಯಾಪ್ ಇಲ್ಲಿ ಮೈನಸ್ ಬರುತ್ತಲ್ಲ. 2 minus 2 pi. ಇಲ್ಲಿ ಯಾವ್ದು ಸ್ಟ್ರಾಂಗರ್ ಅಂತ ನಾವು ಇಲ್ಲ, ಮೈನಸ್ ಕೆ ಕ್ಯಾಪ್ ಪ್ಲಸ್ ಕೆ ಕ್ಯಾಪ್ ಕೊಟ್ಕೊಂಡಿದೀವಿ. That is equal
Option
to
A.
mu naught by 4 pi I by a into 2 minus 2 pi into k cap. ಅದು ಪ್ಲಸ್ ಕೆ ಕ್ಯಾಪ್ ಆದ್ರೆ ಕೆ ಕ್ಯಾಪ್ ಮಾತ್ರ ಚೆಕ್ ಮಾಡುವ. mu naught by 4 pi I by a into 5 plus 2 ಇಲ್ಲ, ಇಲ್ಲಿ 2 pi ಆದ್ರೆ ಆಗ್ತದೆ. And moreover there is a minus. ಇದಾಗ್ತದಲ್ಲ?
Yes, sir.
Yes, sir.
Because if you can write 4 pi minus 2 pi minus 2 ಅಂತ ಬರಿಬೇಕಾದ್ರೆ ಒಂದು minus, yeah, you have to take it outside. Yes. Right. Fourth one. ಇದು ಸ್ವಲ್ಪ ಡಯಾಗ್ರಾಮ್, ಅದು ಹೀಗೆ ಅದು. ಇಲ್ಲಿ ಇದು, these are only the distances. ಇದು ವೈರ್ ಅಲ್ಲ. they are all distances. Wire is only this much. Current is like this, and this is A, this is A, this is O. So current flows like this, like this, like this. And if you want to see what is the magnetic field due to that straight part of the wire, so it is like this, like this, like this. So here, here, and here. No contribution from this wire. 0 here, because it is along the wire. What about this one? You have to clasp it with right hand such that thumb shows the direction of current. Remaining fingers show inside. So from this part, it is inside, into. What about this one? It is like this, outside, correct?
Yes, sir.
This part of the wire will produce outside magnetic field. So B2 is outside. Hope you have followed. This is outside, this is inside.
Yes, sir.
Idu inside madutte, illi idu outside madutte. So divide it into pieces. 1, 2, 3. So B0 is equal to B1 plus B2 plus B3. Illi namge yavadu strong, yavadu weak talebisilla. K cap, I cap, J cap kotidaralla. So accordingly we can write it. B0 is equal to B1 due to straight wire, mu naught by 4 pi I by distance A. Edge aitado, center alla, 2I by D alla. Then this is inside. So inside means it is minus K cap, correct?
Yes, sir.
Definitely K cap horagide. It's outside coming is named as K cap. Illi inside bartade. This is outside. Adan plus K cap tekolbodu. That is equal to mu naught N I by 2R plus K cap plus 0. This one has no contribution, 3. So what is the net magnetic field? B is equal to mu naught
Multiply and divide by pi.
Bekagtada? Yes, 4
Yes.
pi here, right? Here you have to multiply and divide by pi. So here you multiply and divide by pi. What you will get? Mu naught by 4 pi I by A into, so here you get minus K. That means
Pi minus 1.
minus
Pi minus 1 K cap.
minus 1 plus pi. Pi minus 1 into K cap.
Fourth option.
Yes. Yes. Yeah. A straight long will actually all dotted lines barbeku. Because I would show that it is infinitely long. So here and a arc and again infinitely long. This is the center. So from here it is A, that is the radius of the circle, arc of the circle, as well as the distance from the straight part of the wire. I, and this is I, same current, and this is I. What is the magnetic field here? So you have to find out the direction first. So it is like this. So here current like this, here like this. So if you just clasp this with the right hand, so it hege barbeku. For this position, it should be like this. Current is coming down to this part, E part of the wire. So if it is coming down, it is coming out. So I will name this as 1, 2, and 3. B1 is coming out. Is it so? Like this.
Sir.
What about this
Yes,
one?
sir.
This one, it should
Out.
look like this. Yes, out.
Out, sir.
B2 is coming out. What about this one? Coming
Out.
out, right?
Out, sir.
Yes. All the three will coming out and that will be in the K cap direction. So simply add up. B naught is equal to B1 mu naught by 4 pi I by D I by A. I think I can write it as 2 times because I can contribute this also.
Yes, sir.
Plus mu naught by 4 pi. So ಇದರಲ್ಲಿ 1 2 ಎರಡು include ಆಯ್ತು. Mu naught by mu naught ni by 2r next ಇದು because it is 1/4 of a circle ಈಗ. It is not complete circle. 1/4 of a circle. So mu naught n I by 2a. N is 1/4 here. Okay. Number of turns. So into K cap into K cap. So what is B naught? Mu naught by 4 pi I by A into
Option 2 plus
2
pi by 2.
plus
Pi by 2.
pi ಇಲ್ಲಿ ಒಂದು extra ಬರುತ್ತಲ್ಲ, multiply and divide by pi. Yes, that is needed. 2 plus pi by 2 into K cap. Pi by 2. Yes. Yes.
4.
Option 4. Sixth. KLA find out ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ತಾ ನೋಡುವ because we have worked out such type of problems. All the current is in clockwise direction. So K cap ಬರ್ಬೇಕು plus K cap. ಮತ್ತೆ ಯಾವುದು ಮೈನಸ್ ಬರುದಿಲ್ಲ. I think this can be the answer, right?
Yes, sir.
Check ಮಾಡಿ ನೀವು. I don't do that because already we did one type of problem. ಆಗಿತ್ತಲ್ಲ ಅದು ಎಲ್ಲ. This also. All the currents are in the clockwise direction. So it should be outside K cap with plus. See?
Yes, sir.
Right? Check ಮಾಡಿ ಬಂತೆ. I think you can do that. There is nothing more needed here. ಎರಡು ಆಡ್ ಮಾಡ್ಕೊಂಡು ಹೌದು ಇದೇ ಬರ್ಬೇಕು 1 by A plus 1 by B. Yes. ಎರಡಕ್ಕೂ mu naught ni by 2r. There is no straight part. So straight wire ನದಿ ಇಲ್ವೇ ಇಲ್ಲ because they don't contribute. Yes. 8 ಇದು ಮಾಡುವ. The unit vectors I, J and K are as shown below. Of course, the problem complete ಆಗಲಿಲ್ಲ. What is the magnetic field at the center? ಅದು first heading ಗೆ ಕೊಟ್ಟಿದ್ದಲ್ಲ. What is the magnetic field at the center? There are 4 wires bent in the form of rectangle, perpendicular lines like this. What is the magnetic field at the center here, which is at a distance A from here, A from here? Now, these two don't contribute, right?
Yes, sir. Yes, sir.
No contribution. No contribution. No. Idalla. Horizontal. Because that point lies along the wire axis. So there is no contribution from this. To find out the magnetic field here, not somewhere else. No contribution. Yes. Only this part and this part, right? So you got direction note. So this part of the wire will produce a magnetic field here. And this part of the wire carrying current away will produce a magnetic field. So you can't treat this as a single wire. ಯಾಕೆ ಗೊತ್ತಾ? ಕರೆಂಟ್ ಉಲ್ಟಾ ಪಲ್ಟಾ ಉಂಟು. ಒಂದೇ ವೈರ್ ಅನ್ನು ಇಟ್ಟು ಅದನ್ನು ನಾವು ತಕೊಂಡಾಗೆ ಆಗುದಿಲ್ಲ. ಆಗೊಂದಿತ್ತಲ್ಲ, ಹೀಗೊಂದು ವೈರ್ ಬಂದು ಹೀಗೆ ಅದು ಕಾಯಿಲ್ ಆಗಿ ಹೀಗೆ ಹೋದ್ರೆ I told that you can replace it by a single wire and a separate coil. ಅಲ್ವಾ? ಹಾಗೆ ತಗೋಬಹುದು ಅಂತ. But ಇಲ್ಲ ಆಗೋಲ್ಲ. These are carrying currents in the opposite direction. So you have to find out the magnetic field. Now when the situation is like this, you have to see how is the magnetic field. ಹೇಗಿದೆ ಅಂತ. So now it is like this. So this part is carrying current like this and this part is carrying current like this. Point is here. Illide. Now this part of the wire is producing magnetic field inside. Adu hege barutte. Here. This is into. What about this one? That is also into, right?
Yes, sir. Yes, sir.
So this is into, it is coming like this. ಆದಷ್ಟು ಸರ್ಕಸ್ ಎಲ್ಲ ಮಾಡ್ತೇನೆ ನಾನು. So it is like this. So both are into. So they produce, this one will produce like this one will produce like this. So they can be added. So ಹಾಗಾದ್ರೆ ಒಂದು ಕಾಯಿಲ್ ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆಯ್ತು at a distance. Sorry, ಒಂದು ವೈರ್ ನ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆಯ್ತು. B is equal to mu naught by 4 pi I by A. ಎಡ್ಜ್ ಆಯ್ತಲ್ಲ, ಎಡ್ಜ್ ಅಲ್ಲಿ ಅದು ಸೆಂಟರ್ ಅಲ್ಲಿ ಅಲ್ಲ, 2 times. ಆಮೇಲೆ ಇಲ್ಲಿ IJK are as shown. Where is IJK? ಅದು previous problem ಅಂತ ಕೂಡ. ಇಂಟು ಆದ್ರೆ
Minus K.
Yes. Which one?
First option.
Minus K. Into adre minus K, right? Because K was shown outside. Yes. Right. The unit vectors IJK are as shown in the diagram. What is the magnetic field at the center? One is clockwise and another is anti-clockwise. Current, there is no contribution from these two edges. No magnetic field, right? Here, illilla magnetic field due to this. So this is carrying current like this. Idu into agtade, idu into, idu outside. This is into the paper, this is outside the paper. So one part hige. So this is like this, and this is like this. So when the current is like this outside, ಹೊರಗಿನ ಕಾಯಿಲ್ ಇದು outside, ಒಳಗಿನ ಕಾಯಿಲ್ ಇದು inside. So ಆಗ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಬೇಕು. ಒಳಗಿನ ಕಾಯಿಲ್ ಸ್ಟ್ರಾಂಗರ್ ಆಗ್ತದೆ, ಯಾಕಂದ್ರೆ ಎರಡಕ್ಕೂ number of turns same, current same. So B is equal to mu naught Ni by 2R. Number of turns same, current same. So R decides. R is smaller for inner coil, so it produces a stronger field, and it is inside, that is minus K cap. So B idanna coil 1 anta idan karitene, 2 anta idan karidre, B1 plus B2 is the magnetic field at the center. B1 is mu naught N I by idan tegonadu, so that is outside, 2B 2R, mu naught Ni by 2R. My K, adike K cap as it is, right? Plus
Yes, sir.
inner coil ige it is minus K cap, mu naught N I by 2 radius A minus K cap. So that is equal to mu naught I by, ಎಲ್ಲದಕ್ಕೂ ಪೈ ಬೇಕಂತ ಅವ್ರಿಗೆ ಎಲ್ಲಿಂದ ತೆಕ್ಕೊಳ್ಳೋದು ಪೈ, ನಾಟ್ Ni by 2R. They have written everywhere pi. Pi ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಅಂಡ್ ಡಿವೈಡ್ ಮಾಡಿದ್ದಾರೆ, ಮತ್ತೆ ಇಲ್ಲಿ ಪೈ ಇದೆ. Let it be mu naught I by 4 into, ಮತ್ತೆ pi by multiply and divide ಮಾಡಬಹುದಲ್ಲ?
Yes, sir.
Mu naught I by 4, 1 by B minus
1 by A.
1 by A into K cap.
K cap.
ಎಲ್ಲಿ ಉಂಟಪ್ಪ? 1 by B minus 1 by A. ಅದು ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ ಅಲ್ಲಿ. I think we are not wrong. ಇಲ್ಲ ಇದರಲ್ಲಿ. So I think you have to write it as minus, right?
Yes, sir.
Correct ಆಗ್ತದೆ. mu naught by 4 pi into pi I, 1 by B minus 1 by A, minus K cap ಕೊಟ್ರೆ ಇದು ಕರೆಕ್ಟ್ ಆಗ್ತದೆ. So this one. ಇಲ್ಲ ಅದರಲ್ಲಿ ಎಂತ ಮಿಸ್ಟೇಕ್ ಇಲ್ಲ. So this is inside is taken minus K cap, outside is taken, yes, correct ಇದೆ. K cap, yes. Right, 10. The unit vectors IJK are shown. What is the magnetic field at O? So ಹೀಗಿದೆ ವೈರ್, ಅದು ಆಕ್ಚುಲಿ ಇಲ್ಲೊಂದು ವೈರ್ ಇದೆ, ಹೀಗೆ, and this distance is not given. That means it is almost along the wire. ಆಯ್ತು ಅದು. So this is A, ಇದರಲ್ಲಿ ಏನಿಲ್ಲ. This is the magnetic field contributed by the 2F wires. ಆಗೊಂದು ಮಾಡಿದ್ವಲ್ಲ, ಹಾಗೆ ಆಗ್ತದ ಅಂತ? ಇಲ್ಲ, ಸ್ವಲ್ಪ ಚೇಂಜ್ ಉಂಟು. So this carries current. ಇದರದ್ದು ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ತಗೊಳ್ಳಿಕ್ಕೆ ಆಗಲ್ಲ, ಯಾಕಂದ್ರೆ because it is very close, it almost along the wire. ಆಯ್ತದು, because otherwise they must have given the distance. So contribution from this wire is here to produce the magnetic field is 0. So B is equal to B1 plus B2 plus B3 B naught. So B naught is equal to B1. B1 is ido. So that produces inside. This produces outside. 0 bartada. Isn't it?
Yes, sir.
Because this part of the wire and this part of the wire, these are all the only two wires which are contributing. This is
Add
current.
ಆಗ್ತದಲ್ವಾ sir?
Huh?
Add ಆಗ್ತದಲ್ವಾ?
Add ಆಗ್ತದೆ, ಒಂದು ನಿಮಿಷ. So this is inside. This is producing magnetic field inside. ಇದ್ರದ್ದು ಹೀಗೆ ಅಲ್ವಾ? Right. This is carrying current. Upper wire is carrying current like this. So outside. This is also outside. Yes. ಎರಡು outside. K cap ಬರ್ತದೆ. Yes. That don't cancel. ಎರಡು K cap ಬರ್ತದೆ. So this will produce a magnetic field outside and this is also outside. So mu naught by 4 pi I by D, I by A plus B20 plus mu naught by 4 pi I by A. Mu naught by ಎಲ್ಲ K cap.
Option B.
Yes. Mu naught by 4 pi 2I by
2I
A
by A.
K cap. Yes. I think we did it once. ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಅಂದ್ರೆ I theta by mu naught by 4 pi I phi by A I phi by B, but A is stronger. ಇದರಲ್ಲಿ ಯಾವ್ದು ಹೊರಗೆ ಬರೋದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ಹೊರಗೆ ಬರೋದು ಇದ್ರದ್ದು, ರೈಟ್?
Yes, sir.
ಅಂದ್ರೆ I by B ಫಸ್ಟ್ ಮೈನಸ್ I by A, ಕರೆಕ್ಟ್?
Yes, sir. Yes, sir.
ಇದಾಗ್ತದಾ?
Fourth option.
Yes. mu naught by 4 pi I phi into 1 by A minus 1 by B. Minus ಹೊರಗೆ 1 by B minus 1 by A, ಕರೆಕ್ಟ್ ಆಗ್ತದೆ. This is outside. B is positive. This is negative with respect to this K cap. Right. Yeah, we have 5 minutes. Magnetic field first ಮಾಡುವ, ಇದನ್ನು later ಮಾಡ್ತೇನೆ. Magnetic field at the point of intersection of the diagonals of a square loop of side carrying current I is. ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಆಗ್ತದೆ. Magnetic field at the point of intersection of the diagonals of a square loop of side A is within single inverted commas carrying current I. So there is a square loop. Square loop means square wire carrying current. So it is like this. Here is a wire, here is a wire. If all the wires have to carry same current, they should be opened somewhere here and they should be given a battery here. Otherwise, they won't carry current. So what is the magnetic field here? That is their question. At the point of intersection of the diagonals, and you know this is A, LA. So ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ this is a limited length, not infinitely long. So now sin phi 1 plus sin phi 2 ಹಾಕ್ಬೇಕಾಗತ್ತೆ. Now if you take one wire and if you consider these angles from here like this, so this is 45, isn't it? Diagonals of a square bisect and at 90 degrees, and this is A by 2. Do you agree? Because this length is A.
Yes, sir.
This is A by 2, this is A, and this is 45 both. They divide equally. And moreover, current is in this direction. So that produces magnetic field inside. This produces magnetic field inside. This produces magnetic field inside. All will add up. So 4 times birthright. Is it okay? Find out the magnetic field due to one wire and write it as 4 times. So it is like
Yes,
this.
sir.
Okay, black iris, yes. So the square loop is like this. Okay. Like this. This is carrying current like this, so I have to clasp it like this. and it produces magnetic field at the center inside. You have to clasp it like this. Then hige clasp ಮಾಡಬೇಕು. So it produces magnetic field at the center inside. This has to be clasped like this. Hope you can see that. ಹೀಗೆ clasp ಮಾಡಬೇಕು, downwards current. So ಅದು ಕೂಡ inside. ಇದು ಹೀಗೆ ಬಂತು. So this has to be clasped like this. ಅದು inside ಬಂತು ಇಲ್ಲಿಗೆ ಆಗುವಾಗ. So it is inside. All will add up. So 4 times ಬರೆದ್ರೆ ಆಯ್ತು. So it is 4 times mu naught by 4 pi I by d, correct, into sine 45 plus sine 45, isn't it?
Yes, sir.
4 times mu naught by 4 pi 2i by a into 1 by root 2 1 by root 2 2 by root 2. ಇದಕ್ಕೆ ಯಾವ್ದಪ್ಪ ಸರಿ ಆಗ್ತದೆ? mu naught by 4 pi ಉಳಿಸ್ಕೋಬೇಕಂತೆ. ಇಲ್ಲಿ 4 16 by root 2 ಆಯ್ತು, ಅಥವಾ ಇದನ್ನ ರೂಟ್ 2 ಮಾಡಿದ್ರೆ 8 root 2, right?
Yes, sir.
ಯಾವ್ದಿಲ್ಲ, 4 times ಮಾಡ್ಕೊಂಡಿದೀವಿ.
First option.
ಆದ್ರೆ 2 root 2 ಉಂಟಲ್ಲ,
Second.
Yes, sir.
8 ಇಲ್ಲಿ ರೂಟ್ 2
2 into root 2. 1 root 2 cancels.
ಇಲ್ಲಿ ಪೈ ಇಲ್ಲ, ಕರೆಕ್ಟಾ? ಅಲ್ಲ 4 ಇಲ್ಲ, 4. So this becomes mu naught by 4 pi. If you divide this into root 2 into root 2, I by a 8 root 2, right? So 2 root 2 ಆಗ್ತದೆ. ಸರಿ ಅಲ್ಲ? Second option.
Yes, sir.
Yes.
Yes.
Yes, yes. Magnetic field at the center of an equilateral triangle of loop side 2L. Equilateral triangle ಅನ್ನ ಓಪನ್ ಮಾಡಿ ಎಲ್ಲಿಯೋ ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿದ್ದಾರೆ, ಅದೆಲ್ಲ ಹೇಳಿಲ್ಲ ಅವರು. So you have to open it somewhere here and you have to pass current so that it passes current in the same direction. ಯಾವ ಡೈರೆಕ್ಷನ್ ಬೇಕಾದ್ರೆ ತಗೊಳ್ಬಹುದು. And this is like a circular loop. All should produce magnetic field at the center inside. ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ಅದು. Hold this with the right hand inside. ಇದು ಕೂಡ inside ಬರುತ್ತೆ. And when you hold this, it will be inside. I need not draw it in a separate diagram. You can follow it. ಎಲ್ಲ ಒಳಗೆ ಬರ್ತದೆ. ಇವಾಗ this is the perpendicular distance. Okay, you draw the median. You will get the perpendicular distance. Since it is equilateral triangle, all the medians will be the perpendicular distances from the center. Now, I want this perpendicular distance or this one, say x. This is 2L, sides are 2L.
Sir,
this
ಅಲ್ಲಿ
is
ಒಂದು
L.
ಮೈನಸ್ ಆಗ್ಬೇಕಲ್ಲ ಸರ್?
Again?
ಡೈರೆಕ್ಷನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಂದು ಮೈನಸ್ ಆಗ್ಬೇಕಲ್ಲ?
ಯಾವ್ದು ಮೈನಸ್ ಆಗ್ತದೆ?
ಇಲ್ಲ ಸರ್.
ಇಲ್ಲ, ಆಡ್ ಆಗ್ತದೆ ಅಲ್ಲ?
ಇಲ್ಲ ಸರ್. ಎಸ್ ಸರ್.
So it is like this. ಹೀಗೆ ಉಂಟು, like this, like this, like this. So this is clasped like this. ಇದನ್ನು ಹೀಗೆ ಕ್ಲಾಸ್ ಮಾಡ್ಬೇಕು. ಇದನ್ನ ನಾನು ತೋರಿಸ್ತಾ ಇರೋದು, this one, it has to be clasped. ಅದು ಒಳಗೆ ಬರುವಾಗ inside. What about this part? ಇದು, this one, it has to be clasped. Yes, inside. What about this one? ಇದು, so it has to be clasped like this. ಹೀಗೆ ಇಟ್ಕೊಳ್ಬೇಕು. ಅದು ಬರುವಾಗ ಒಳಗೆ ಬರುವಾಗ ಹೀಗೆ ಆಗ್ತದೆ. So like this. ಇಲ್ಲಿ ಆದ್ರೂ ಹೊರಗೆ ಬರ್ತದೆ, but here it comes inside. So ಎಲ್ಲ ಆಡ್ ಆಯ್ತು. So 3 times ಬರೆದ್ರೆ ಆಯ್ತು. But 3 times ಬರಿಬೇಕಾದ್ರೆ 1 time ಗೊತ್ತಿರ್ಬೇಕಲ್ಲ ಈಗ. And can I write this as for 30 degrees for equilateral prism? Isn't it? For an equilateral prism, that median bisects the angle. So it is 30 degree. ಅದು 30 degree ಆದ್ರೆ, and this is L, x ಆದ್ರೆ x ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ಇಲ್ಲಿ ಎಷ್ಟು ಅಂತ. So that is cos 30 is equal to, ಅಲ್ಲ sin 30 ಬೇಕಾದ ಅಂತ, hypotenuse ಗೊತ್ತಿಲ್ಲ ಅಲ್ಲ, tan 30 ಆಗ್ಬೋದಾ? adjacent by opposite, opposite by adjacent, correct?
Yes, sir.
That is better. Tan 30 is equal to opposite side by adjacent side. Is it so? ಸರಿ ಉಂಟಲ್ಲ?
ಎಸ್ ಸರ್.
sin 30, yes,
1 by root 3.
yes, 1 by root 3 is equal to x by L. So what is x? L by root 3.
L by root 3.
ಅದಾಯ್ತು. So we know the perpendicular distance from each wire to the center. Adu sikkitu. Perpendicular distance from each wire to the center. Perpendicular distance from this wire to the center. Namage innen beku? Sin phi 1 and sin phi 2 beku. Alva? For each wire, it bekala. For example, for this wire, this is phi 1 and this is phi 2. Ade eಷ್ಟಾಗ್ತದಪ್ಪ? ಇದು 30 ಆದ್ರೆ ಇದು 90 ಆದ್ರೆ 120. 120 ಆದ್ರೆ 60 ಆ?
Yes, sir.
Phi 1 is equal to phi 2 is equal to 60. 60, 60. So this is 60, 150, 30. Yes, 60. So what is B at the center? 3 times mu naught by 4 pi I by D. I by distance is L by root 3 sin 60 plus sin 60. Okay, correct undala?
Yes, sir.
Mu naught by
Yes, sir.
4 pi root 3 I by L. Sin 60 is root 3 by 2, 2 root 3 by 2. ಸರಿ ಆಯ್ತಲ್ಲ?
Yes, sir. First option.
This will be root 3, 9. ಹೇಗೆ ಉಂಟು ಆಪ್ಷನ್ಸ್ ಎಲ್ಲ? mu naught by 4 pi ಇದೆ,
9
I
mu
by L ಇದೆ. Yes.
by L.
B naught is equal to mu naught by 4 pi I by L ಕಾಮನ್ ಆಗಿ ತಗೊಂಡಿದ್ದಾರೆ. ಉಳಿದದನ್ನೆಲ್ಲ ಒಟ್ಟು ಹಾಕಿದ್ರೆ ಆಯ್ತು. 3 times 9, 18, 9.
Yes, sir.
9 mu naught I by 4 pi R. Yes. So ಈಗ ಈ ಪ್ರಾಬ್ಲಮ್ ಗೆ ಹೋಗುವ. ಇದನ್ನು ಮುಗಿಸ್ಬಿಡು ಅಲ್ಲ? The last problem. This one.
Yes,
Where is it now? Yes. Yes. A steady current I goes through a wire loop of PQR having the shape of a right angle triangle. Yes. ಇಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ. A steady current I goes through a wire loop of PQR having the shape of a right angle triangle with PQ is equal to X and PR is equal to 4X, QR is equal to 5X. If the magnitude of the field at P due to this loop is K times so much, what is the value of K? So it's a PQR is a right angle triangle. PR, QR ಎಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈಗ ಹೇಗೆ PQR ಹಾಕಬೇಕು? Here 5X is QR. QR ಅಲ್ಲಿ 5X ಬಂದ್ರೆ I think P should be the 90 degree. ಇಲ್ಲದ್ರೆ QR diagonal ಆಗುದಿಲ್ಲ ಅಲ್ವಾ? This is
Yes,
the right
sir.
angle triangle. It should be P here, QR. ಹೀಗೇನೆ ಬರಬೇಕು. Otherwise QR cannot be hypotenuse. ಇದರಲ್ಲಿ ಜಾಸ್ತಿ ಅದೇ ಅಲ್ವಾ? And PQ is 3X. This is 4X. Am I right?
Yes, sir.
The magnitude of the magnetic field P due to this at the point P ಅವರಿಗೆ ಬೇಕಾದ್ದು. Magnitude of magnetic field at P. ಹಾಗಾದ್ರೆ ನಮಗೆ ಬಾರಿ ಈಸಿ ಆಯ್ತು. Because at P, this QP and RP do not contribute to the magnetic field, right?
Yes,
So
sir.
magnetic field is only due to
QR.
QR.
ಅದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸ್ ನೋಡಿದ್ರೆ ಆಯ್ತಲ್ಲ. ಅದನ್ನೊಂದು ಎಸ್ ಅಂತ ತಗೊಳ್ಳುವ. Find out the magnetic field here due to this conductor. So ಇದ್ರದ್ ಮಾತ್ರ ನಮಗೆ ಬೇಕಾದ್ದು. QR ಇದ್ ಮಾತ್ರ. So now to find out the perpendicular distance, now ಇದ್ರಲ್ಲಿ easiest method ಸ್ವಲ್ಪ geometry ಜಾಸ್ತಿ physics ಗಿಂತ. We will do it like this. We will find out the area of the triangle, full triangle, right angle triangle in 2 ways. Because this is the perpendicular distance, this is the base, height, base. ಇನ್ನೊಂದು ರೀತಿಯಾಗಿ ಅಂದ್ರೆ height, base. Both the areas must be same, right? Half base into height must be equal to same area half base into height. Correct ಅಲ್ಲ? ಎರಡು ಒಂದೇ ಅಲ್ಲ, ಒಂದೇ ಟ್ರಯಾಂಗಲ್ ಅಲ್ಲ.
Yes, sir.
Base into height, base into height. Half of cancel ಆಯ್ತು. QR is 5X. PS, that is what I want. Half cancel ಆಗಿದೆ. PR 4X. into QP height. Hope you have followed.
Yes,
Yes, sir.
ಒಂದು x cancel ಆಗುತ್ತೆ. PS is equal to 12 by 5x. ಒಂದು part ಆಯ್ತು. And you must also calculate sin phi 1 plus sin phi 2. ಇದಲ್ಲ phi 1.
Yes, sir.
This is phi 2. ಆ diagram ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. So we are calculating the magnetic field due to a wire somewhere here. ಅವಾಗ ಇದು phi 1 ಇದು phi 2. ಇಲ್ಲಿ wire ಇಲ್ಲಿದೆ. QR is a wire. ಸರಿ ಅಲ್ಲ? ಈಗ we have to find out what is that phi 1 phi 2. PS ಆಯ್ತು. What is the method of finding phi 1 and phi 2? ಆಗ ಇದು ಬೇಕು ನಮಗೆ. This QS and RS ಬೇಕಾಗ್ತದೆ. ಇಲ್ಲಾಂದ್ರೆ sin phi 1 is opposite side by ಇದು 90. This is 90. Opposite side by hypotenuse. So how to find out QS? PS ಇದು Pythagoras theorem ಹಾಕ್ಬೋದಲ್ಲ. QS is equal to square root of
Minus SP.
hypotenuse square 9x square minus this one. Correct? ಗೊತ್ತಾಗ್ತಾ ಉಂಟಲ್ಲ?
Sir.
90 degree ಇದು opposite side. Sorry, hypotenuse. ಇದು
12 by
9x square
4.
144x square by 25. QS square, because this square plus this square is equal to hypotenuse square. So this square is equal to hypotenuse square minus this one. So ಇದು ಎಷ್ಟು ಬರ್ತದೆ ಅಂದ್ರೆ this is 25 common.
225.
This is 25 into 9.
225.
225 minus 144 ಎರಡಕ್ಕೂ x square ಇದೆ by 25. QS is equal to this is 225 minus 144 means 56 81 ಅಲ್ಲ 9x
Yes.
by 5, right?
Yes, sir.
Similarly another one ಇನ್ನೊಂದು ಬೇಕು ನನಗೆ ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ we want ಇದನ್ನು ಡೈರೆಕ್ಟ್ ಪೈಥಾಗರಸ್ ಬೇಡ 5x minus SR is
9x
equal
by
to
5.
yes 5x minus 9x by 5 ಅದಾಗ ಎಷ್ಟಾಯ್ತು 25 minus 9 16x by 5 correct ಅದು SR ಆಯ್ತು ಓಕೆ ನಾವು ಇದು ಎಂತ ಡೈರೆಕ್ಟ್ ಫಾರ್ಮುಲಾ ಈಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ P ಈಸ್ ಫಾರ್ಮುಲಾ is mu naught by 4 pi I by D into sin phi 1 plus sin phi 2. Mu naught by 4 pi I by distance idala PS perpendicular distance 12x by 5 into sin phi 1 opposite side S Q, right?
9x by 5 divided by 2x.
Yes. Sin phi 1 ಗೆ opposite side is S.
SQ.
ಅದೆಷ್ಟು ಬಂದದು ಇಲ್ಲಿ ಉಂಟಲ್ಲ
9 by 5.
9x by 5 hypotenuse 3x plus sin phi 2 16x by 5
divided by 4x.
yes ಪೆನ್ನಿಗೆ ಸಸಿವ್ ಆಗ್ತದ ಅಂತ ಏನೇನೋ ಬರೀತಾ ಉಂಟು 16x by 5 divided by 4x ಮುಗೀತು ಅಲ್ಲಿಗೆ BP magnetic field at P is mu naught by 4 pi 5I by 12x. This will be x cancel idle 9 by 15 plus 16 by 20, right?
Yes, sir.
BP is equal to mu naught by 4 pi 5 ಇಲ್ಲಿ ಕಾಮನ್ ಸಿಗ್ತದೆ ಇದೊಂದು 27 ಅಲ್ಲ 12 ಬರ್ತದೆ ಅಲ್ವಾ
7.
7.
7 5I by 12 7x 12x 7 ಸರಿ ಆಯ್ತಲ್ಲ 5 ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತಲ್ಲ ಇವರಿಗೆ ಯಾವ ತರ ಬೇಕು ಫಾರ್ಮುಲಾ mu naught by 48 pi I by x ಇಲ್ಲಿ ಬರ್ತದೆ ಅಲ್ಲ mu naught by yes mu naught by 48 pi I by x ಅಲ್ಲಿಗೆ 7 ಆಯ್ತಾಗಾರೆ that is mu naught by 48 pi x I into 7 so 7 is the one which they want k right
Yes, sir.
ಸ್ವಲ್ಪ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಜಾಸ್ತಿ ಸೊ ಯು ಶುಡ್ ವರ್ಕ್ಔಟ್ ಸಚ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಟ್ ದ ಎಂಡ್ ಇದು ಉದ್ದಕ್ಕೆ ಹೋಗ್ತದೆ ಅಂತ ಹೇಳಿದ ಕೂಡಲೇ ಬಿಟ್ಟು ಹೋಗ್ಬೇಕು ಫಸ್ಟ್ ರೌಂಡ್ ಅಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ದ ಸೆಕೆಂಡ್ ರೌಂಡ್ ಸಚ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅದನ್ನ ಎರಡನೇ ರೌಂಡಿಗೆ ಇಟ್ಕೋಬೇಕು ಬಿಕಾಸ್ ಈವನ್ ದೋ ಯು ನೋ ಇಟ್ ಟೇಕ್ಸ್ ಅ ಲಾಂಗ್ ಟೈಮ್ ಅಂಡ್ there is no guarantee that if you are under a tension finally when you land up with some answers that may not be the exact answer ಸ್ವಲ್ಪ ಆದ್ರೂ 4 3 ಎಲ್ಲ ಬರೋ ಚಾನ್ಸಸ್ ಇರ್ತದೆ so second round ಗೆ ಇಟ್ಕೋಬೇಕು okay so thank you for attending the class if you have any doubt you can ask or later also otherwise we will have a fine meal and we will meet later ಮಧ್ಯಾಹ್ನ 2:30ಗೆ ಸರ್ ಬರ್ತಾರೆ chemistry bonding chemical bonding okay friday ನಿಮಗೆ ಒಂದು maths test ಉಂಟು friday ನಾನು ಅದೇ ಅನೌನ್ಸ್ ಮಾಡ್ತೇನೆ mock test okay thank you